All you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready.
Establishing your
All you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready.
Hello everyone, how are you all? And welcome to this amazing DSA marathon, the next session of our DSA marathon. Right? How are you guys? कैसे हो आप सब? How is everyone? Hi Subham, how are you? Hi. Hi Minsk. Moon revision on recursion. ठीक है यार, like we already had one masterclass on recursion actually. If you are saying for more practice, maybe we can have some topics similar to recursion later, like backtracking or maybe recursion itself. We will have more practice. Otherwise, if you will see backtracking or even in DP, right? We have 3 DP classes. Okay, that are also very good. Right? Hi Chitich, how are you? गुड इवनिंग सर. फन कर लो जिंदगी में क्या. ओके भाई, थोड़ा छोटा नाम रख लो या फिर नाम बता दो जैसे क्षितिज ने बता दिया. ठीक है, बढ़िया यार. अच्छा, फर्स्ट ऑफ ऑल प्लीज क्लियर इफ आई एम क्लियरली ऑडिबल एंड विजिबल टू एवरीवन. ओके, हाय, यस, हेलो हेलो हेलो. am I clearly audible and visible to everyone? Okay, I think there is little lag that is coming. Is it from my side or is it for every? Okay, video is lagging, right? Okay, give me 1 minute. Is it fine now? हाँ, अब ठीक है ना? अब आई थिंक सही होगा, राइट? एक क्वेश्चन, हाँ यस पूछो यार, क्या क्वेश्चन है? यू कैन आस्क यस, जो भी आपका क्वेश्चन है. सर, सब सीरीज को प्लेलिस्ट में ऐड कर दीजिए, डीएसए का जो प्रैक्टिस करवा रहे हैं. हाँ यार, मैंने बोला वो ऑलरेडी प्लेलिस्ट के लिए. मैं आज फिर बोलता हूँ उसको प्रायोरिटी में लेने के लिए. यार समवन फ्रॉम द टीम इज सीइंग, प्लीज यार एक प्लेलिस्ट बना लो. और हमने ऑलरेडी 6 वीडियोस करे हुए हैं, ये 7th वीडियो है. जस्ट ग्रुप इन द प्लेलिस्ट ऑफ दिस डीएसए मैराथन, राइट? I hope it should be fine now, right? Video is not lagging, audio is fine, everything is fine. Can we start, guys? Subham, yes. Chetish, everyone. कॉन्फिडेंस नहीं आ रहा है, सॉल्व 5 प्रॉब्लम्स वन स्टैक. ठीक है, देखो यस, अब जो भी ये पर्सनल डाउट्स है, मैं क्या करता हूँ, मैं हर 1 घंटे बाद आई मोस्टली टेक सम डाउट सेशंस. तो आपको जो भी पर्सनल डाउट्स है हम लोग उसमें से डिस्कस कर लेंगे, ठीक है. ग्रेट. कॉन्फिडेंस नहीं. सर वेयर इज द क्वेश्चन लिस्ट? ओके, क्वेश्चन लिस्ट मैं आपको अभी बता देता हूँ. आई विल गो थ्रू ऑल द क्वेश्चन जो हम आज सॉल्व करने वाले हैं. आई विल गिव यू अ गो थ्रू ऑफ दैट, ठीक है. ग्रेट. चलो यार, सो लेट्स स्टार्ट द, लेट्स शेयर द स्क्रीन. प्लीज यार अपना अटेंडेंस लगा दो. प्लीज लाइक द लाइव. वी हैव 10 व्यूअर्स अराउंड, सो प्लीज लाइक कर दो स्ट्रीम को. ओके. हाँ, एजेंडा आई विल डिस्कस द एजेंडा. डोंट वरी ऑन दैट पार्ट. वी विल डेफिनेटली डिस्कस द एजेंडा. सो is my screen visible? Is my screen visible now? Yeah, great. So let me change the orientation. Yeah, okay. So what do we have in our box today? As we know, we'll be starting with linked list. So first of all, if you are someone who does not know linked list, don't worry, I will be taking everything from scratch. But if you are having some basic idea of linked list now, like even if you know how to add a new node, how to remove a node, that's a basic thing, then also it will be good. Okay, we are good to go if you have the basic idea of linked list even, right? So that is what we are doing. uh, let's see. Okay, let's discuss. So we'll be starting with, first of all, understanding what linked list is, understanding the basic idea of linked list. Okay, understanding the basic idea of linked list. Second thing that we'll be doing is we will discuss about a very basic about the data structure, right? So whenever we start with data structure, right, what we first understand how to create it. We first understand how to iterate it. We'll first understand how to find the length. That is the basics that will be discussed. Iterating, finding the length, and all of that. After that, we'll be solving a lot of problems on linked list, right? Problems are there. What are the problems? So I have a couple of problems here. If you will see, I will start with the very basic questions and I will go advance it to some advanced or good level of questions also. For example, we'll start with how we can print a linked list, how we can find length of a linked list, how we can find the middle node of a linked list. Okay. Then we will discuss how we can remove duplicates from a sorted linked list. Then we will discuss how we can reverse a linked list, how we can rotate a linked list, how we can find the intersection point of a linked list. When we have two linked lists present, how can we find the intersection point of them? How we can detect a loop in a link. So this loop is a very important concept, and there are three problems that are being formed out of this concept. First is how we can detect loop in the linked list. Second is how we can find the length of the loop. Okay. And third is how we can remove the loop from the linked list. Okay. So these are three concepts that we take here about loops. And then we have this merge to sorted linked list. Okay. And we have this delete without header pointer, right? So like I've selected these problems because all these problems are of good level, from easy to medium hard problems we have taken, and they all are of good level. Okay. uh, we will see how much of them we can solve in class. I will try to cover as much as problems possible in the class itself, and the remaining problems will be having in as the assignment part. Okay, so this session will be of 4 hours starting from 7. We'll be having this session up to 11 p.m. Okay, so it's a 4-hour session that we'll be having. Okay, डिले हुआ है क्या? कुछ नेटवर्क दिक्कत हुई है क्या? मेरे फोन पे इट्स स्टॉप्ड वर्किंग. ऑल गुड है? पता नहीं मेरे मेरे फोन पे नहीं चल रहा है. ओके, अब आ गया. ठीक है. आई थिंक कुछ प्रॉब्लम थी यार इसमें मेरे पे, तो आई थॉट कि इट्स हैविंग अ प्रॉब्लम. ठीक है. सो वर्किंग गुड, राइट? ओके, ग्रेट. हाय कार्तिक. सो ये है, ठीक है. सो दिस इज आवर होल एजेंडा. विल बी सॉल्विंग दीज गुड नंबर ऑफ प्रॉब्लम्स ऑफ लिंक लिस्ट. ओके, as we discussed, right? तो अब लेट्स स्टार्ट विद द लिंक लिस्ट। लिंक लिस्ट बेसिक पढ़ाओ मुझे, बेसिक ऑपरेशन तो पता है, सिंटैक्स वगैरह और लॉजिक बिल्डिंग लॉजिक, हाँ बिल्कुल बेसिक से ही पढ़ाएंगे यार मोहसिन, ओके बेसिक से ही पढ़ाएंगे, कोई दिक्कत नहीं है। तो पहले तो आते हैं लिंक लिस्ट का यूज क्या है और लिंक लिस्ट होता क्या है, ठीक है। तो देखो लिंक लिस्ट क्या होता है ना, लिंक लिस्ट एज द नेम सजेस्ट, लिंक लिस्ट इज रिफर्ड एज collection of nodes linked with each other, ठीक है। ये होता है लिंक लिस्ट। हाय शुभ, हाउ आर यू, ठीक है। अब ये लिंक लिस्ट का यूज क्यों होता है, आप बोलोगे अभिनव हमने ऑलरेडी इतने सारे डेटा स्ट्रक्चर पढ़े हुए हैं, ठीक है, हमने देखो एरे पढ़ा हुआ है, ठीक है। और एरे क्या करता है, एरे यार हमारा एक फिक्स साइज डेटा स्ट्रक्चर होता है जिसमें हम लोग कुछ एलिमेंट्स को स्टोर करते हैं, ठीक है। भाई ये एरे है, इसका ये साइज है, हम इसमें एलिमेंट्स को स्टोर करते हैं। अब लोग हमें एरे तो पता है, चलो एरे में एक डिसएडवांटेज था, ठीक है। आई नेवर अंडरस्टैंड लिंक लिस्ट, व्हाई आई डोंट नो, डोंट वरी वसीम, I will try my best to get it understand today for you, okay? So what's the use of linked list? तो मैंने बोला भाई हमारे पास एरे है, ठीक है। अब अगर हमें कोई भी सीक्वेंस ऑफ डेटा स्टोर करना होता है, कुछ भी सीक्वेंस ऑफ एलिमेंट स्टोर करने होते हैं, तो हम लोग डायरेक्टली उसको एक एरे में स्टोर कर सकते हैं, कोई दिक्कत नहीं है। हमने एक एरे बना ली फिक्स साइज की, ठीक है, और उसको इसमें स्टोर कर लेंगे इस एरे में, ठीक है। अब एरे की एक होती है आई विल से लिमिटेशन कि एरे एक फिक्स साइज की होती है, ठीक है। अब अगर एरे फिक्स साइज की होती है तो हमने कहा भाई ठीक है कोई बात नहीं, हम इसके लिए एक तरीका ढूंढ लेंगे, हम क्या कर लेंगे, हम वेक्टर्स यूज कर लेंगे, वेक्टर्स या फिर हम एरे लिस्ट यूज कर लेंगे। अब वेक्टर्स और एरे लिस्ट क्या होता है, वेक्टर एरे लिस्ट का मतलब होता है कि भाई यहाँ पर हम लोग एक डायनेमिक साइज के एरे यूज कर लेंगे, तब भी ठीक है। अभी ना यार हमारे पास एरे भी है, हमारे पास वेक्टर है, एरे लिस्ट है, हमें लिंक लिस्ट की जरूरत क्या है, ठीक है, क्या जरूरत है, क्योंकि लिंक लिस्ट भी एक तरीके से आप बता रहे हो कि सीक्वेंस स्टोर करेगी, कलेक्शन स्टोर करेगी, ठीक है। ठीक है ये हम लोग करेंगे, यस एरे की गुड क्वेश्चन मैराथन करेंगे, बिल्कुल करेंगे, ठीक है। हाँ और एरे में कॉन्टिन्यूस मेमोरी लोकेशन होते हैं, तो उससे हमें कोई दिक्कत नहीं, अगर कॉन्टिन्यूस भी हो रहा है तो कोई हमें परेशानी नहीं होनी चाहिए उससे, राइट। देखो एक लिमिटेशन आती है एरे में, लिमिटेशन क्या आती है यार, मान लो आपके पास एक एरे है, ठीक है, मान लो ये आपकी एरे नंबर 1 थी, ये आपकी एरे नंबर 1 थी, ठीक है, और मैं यहाँ पे एक एरे नंबर 2 भी बना देता हूँ, आई विल मेक अ एरे नंबर 2 ऑल्सो है। एड्रेस स्टोर करता है वो सारी चीजें साइड की है, मेन जो था वो क्या है, मान लो आपके पास एक एरे दी थी, आपके पास एक दूसरी एरे दी थी, ठीक है, ये आपकी एरे 2 है, ये आपकी एरे 1 है। अब यार होता क्या है कि मान लो मैं आपसे बोल रहा हूँ कि यार मुझे क्या करना है ना, मुझे इस एरे के स्टार्टिंग के 4 एलिमेंट्स उठाने हैं और इस एरे के स्टार्टिंग के 3 एलिमेंट्स उठाने हैं और उसको उठा के एक नई एरे बना देनी है। हाय प्रखर, हाउ आर यू, उसको उठा के एक नई एरे बना देनी है। बात समझ रहे हो, बात समझ रहे हो। अब एरे में क्या होगा ना, हम एक नई एरे बनाएंगे, हम इस एरे से एलिमेंट निकालेंगे, उस एरे में डालेंगे, बहुत लंबा ऑपरेशन होगा, यस और नो, यस और नो। बट लिंक लिस्ट में एक्स्ट्रा स्पेस भी लेंगे। लिंक लिस्ट पता है क्या होगा भाई, बहुत ईजी है, हम यहां का लिंक हटाएंगे, उसको यहां से ऐड कर देंगे और इस लिंक को यहां से हटा देंगे, हमें बस कुछ लिंक्स को चेंज करना होगा और हमारा काम हो जाएगा। समझ रहे हो बात को, समझ रहे हो बात को। हाँ मैं नोट शेयर कर दूंगा, ठीक है, मैं नोट शेयर कर दूंगा। अब बात समझ रहे हो, आपका काम ऐसे हो जाएगा चुटकियों में। इवन हम आज जितने भी प्रॉब्लम सॉल्व करेंगे ना लिंक लिस्ट के, आप देखना आज हम जितने भी प्रॉब्लम सॉल्व करेंगे लिंक लिस्ट के, वो सारे ही प्रॉब्लम है, अगर आप देखोगे हम कहीं भी देखो, अगर आप एरे देखो, मान लो मैं आपसे बोलूं कि आप एक एरे को रिवर्स करो या आप एरे को रोटेट करो, तो हम लोग क्या करते हैं, हम करते हैं भाई इस एलिमेंट को यहाँ लाओ, इसको यहाँ से वहां स्वैप करो, ये 3 एलिमेंट यहाँ आएंगे, मतलब बहुत सारे लूप चलाते हैं, क्या क्या करते हैं हम लोग, करते हैं राइट। This all we do. Okay, Sivraj, I will speak in English. So I'm saying what we do in array. In array, if we have to do any operation, we have to do a lot of tasks. We iterate the array, we make a lot of swaps, make a lot of changes, right? And the problem comes about time complexity, space complexity. Extra space is required, extra time is required. But in linked list, this problem goes. If you have to make any changes in your existing linked list, you have to just do that change in the link. आप बस लिंक्स को चेंज करोगे, इस लिंक को वहां कर दो, इस लिंक को इधर कर दो, इस लिंक को उधर कर दो, आपका काम हो जाएगा. Even if you will see today in our session, whatever problems we will be solving, in most of the problem we will be just modifying the links of your linked list. That's it. हम मोस्ट ऑफ द प्रॉब्लम्स में हमारी लिंक लिस्ट के जो लिंक्स होते हैं, जो एजेस मान लो बोल सकते हैं, उन्हीं को मॉडिफाई करेंगे. आफ्टर मॉडिफाइंग दैट आवर प्रॉब्लम विल बी डन, राइट. सो हम ये बोल सकते हैं कि जो लिंक लिस्ट का यूज है, द यूज ऑफ लिंक लिस्ट, द मेजर यूज ऑफ लिंक लिस्ट comes where we have to do a lot of modifications, a lot of changes in our data structures, when we have to continuously add new elements in the top, in the middle, in the front. Because if you will see, let's say if there's a vector present, right, and I will ask you to insert a new element in the vector, it will take a lot of time. It will take order of n time complexity, right? But in linked list it will be done just like very easily. ठीक है, we can disconnect link. अब जैसे you all know, right, train, right, we all have traveled in railway, okay, at least once in a life till now you must have traveled in railway, okay. So railway में क्या होता है, we have lot of coaches, cars are connected with each other, right. अब is, and this is let's say an engine, this is the engine, thanks to my drawing, okay. अब ये engine है. अब it's not like okay, the train is connected. The train is having coaches. If you want to put these engines, you can detach from this train and you can put it anywhere else where you want. This is the advantage, right? Just think that if the engine of all the trains are connected, it will be a very problem. Okay, it will be a very big problem, right? तो अगर बीच में कोई प्रॉब्लम होती है, you will be having a issue. So that is the thing. So this is what the linked list is, right? अब देखते हैं हाउ अ लिंक लिस्ट लुक्स लाइक. अब देखो, वन मोर थिंग अबाउट लिंक लिस्ट इज दैट इट इज अ यूजर डिफाइंड डेटा स्ट्रक्चर. ठीक है. सो इफ यू विल सी, इफ यू रिमेंबर, हम लोग एरे कैसे बनाते हैं. तो एरे हम सिंपली, इफ यू हैव टू क्रिएट अ एरे, वी सिंपली राइट इन ARR10. And what will happen? An array of size 10 is created. आपकी एक एरे 10 साइज से क्रिएट हो जाएगी जब भी आपको एरे बनाना है. ठीक है. अगर मैं बात करूं कि आपको एक स्ट्रिंग बनानी है, तो स्ट्रिंग यू कैन इजीली क्रिएट लाइक दिस, राइट. एंड वट एवर यू वांट यू कैन क्रिएट लाइक दिस. बट इफ आई विल आस्क यू दैट यू हैव टू क्रिएट अ लिंक लिस्ट, there is no specific way of creating a linked list, okay. Even if you know the only fundamental data structure that is provided by a programming language is array. Array is the only fundamental data structure that is being provided. All the other data structures are actually user defined. जैसे stack है. अब stack क्या है? Stack is nothing but this array. The only thing is there is a specific property that we have to insert from the top and remove from the top. So if you have learned stack from the very basics, you must be knowing that stacks and queues and all of these data structures are implemented through array and linked list at the backend. तो ये सारे डेटा स्ट्रक्चर बैकएंड में array और linked list के थ्रू ही इंप्लीमेंट हो रहे होते हैं. बात समझ में आ रही है? तो this is the thing. So similarly, this linked list is also a user defined data structure. We define it. अब you will say, Abhinav, how can we define a data structure? It's very easy. So in linked list, what happens is, in linked list we have two things. First of all, as I said, linked list is collection of nodes, right? So we should first of all understand that how can we create a node, like how a new node can be created. That is the major thing that we should understand, right? And how we can understand that? So I will say do one thing. A node contains two things. A node contains a value and a node contains a next pointer. These are the two things that a node contains. Right? Now, how can we represent a node? So every node in linked list has some data inside it. You can either say value, you can either say data. Every node in linked list actually has a data inside it. Let's say the data is value is 7. Okay. It has a data inside it. And after this data, what it has is, It has multiple nodes, like it is, let's say 8 here, let's say 2 here, 5 here, and 6 here. Okay, and you will be making like this. So this is a linked list that I've created, and as I told you, each linked list contains two things. It contains Each node contains the two things. It contains data of its own, and it has a next pointer that points to the next node. It has a next pointer that points the next node. That is what a node of a linked list contains. That is what a node of a linked list contains, right? Great, great. चलो बढ़िया ठीक है. For example, this is the head of your linked list. अब what is head? अब देखो, when we have a array ना, in array we have indexing, so we can access any element of the array very easily. But in linked list we do not have any indexing. We cannot access using index. Okay. But what happens is in linked list that we have the head of the linked list. We have the start point of the linked list. And if you know the start point of your linked list, you can go through the end of the linked list. You can iterate through the whole linked list. There is no problem that happens. Okay? अगर आपका start point है, you can go through the complete linked list. Right? Right? So this is what head is. Acha, now I want a response from you guys. Let's see if I will print here see out head data. तो what will be printed? क्या print होगा? कोई बताएगा? Can anyone tell me what will be printed when I will say head data? Anyone? Sivraj, Mohsin, yes, Prakhar, Subham, Wasim, Subh. Guys, it will be just 7, right? Why 7? Because head is 7. This head is pointing to the first node of your linked list, right? First node of your linked list. And if it is pointed to the first node, I will simply say, okay, it is 7, right? Can you please explain sentinel node? Yeah, even I don't know what is sentinel node, Wasim. What is sentinel node? Yeah, let me check. Sentinel Island मैंने सुना था. A dummy node that goes to the at the front of the linked list. Maybe they are saying that sentinel nodes are those nodes. So in Geeks for Geeks also we have a article for that. Okay, so sentinel nodes are basically some dummy nodes that we take at the front and at the last uh, to just avoid the overbound maybe कि out of index now बोल सकते हैं, like in array. But I have even heard it this first time. I don't know, it is a very important thing. But they are just dummy node that does not contain any value, and they are put at the start and end of the linked list. Okay, whatever, this is not important. Leave it. Cool. ठीक है. So no, not leaf node. Leaf nodes are real. They are saying they are dummy nodes. They are just make there, but they are not a part of the linked list. Okay. Yeah. I also heard it first time. That is the thing. Okay. Cool. So guys, yeah, like kar do. We have 18 people in the class. Okay, 18 20 people. Please hit the like button. Please put your attendance. Okay. Let's make the like at least to 25. Okay. ठीक है. ये हो गया. अब ठीक है. अब देखो, whenever we solve a question, okay, we first of all understand is leaf exists leaf node in, no, what is leaf node? This is not a tree, guys. Why leaf node concept is coming here? This is not tree, right? Leaf node concept comes in tree graph, not even graph, just tree, right? That will not come here. So this is the thing, right? Acha, if I will ask you that how can you go through all the nodes of this linked list, what will you tell me? Can anyone tell me? If I will ask you how I can go through all the nodes of the linked list, so कैसे होता है हिंदी में? देखो वो तो ऑब्वियसली बात है, हिंदी में बोलूंगा तो जो हिंदी ऑडियंस को अच्छा समझ में आएगा, बट वी हैव सम आई थिंक इंग्लिश ऑडियंस आल्सो, सो आई हैव टू टेक केयर ऑफ एवरीवन, बट स्टिल ठीक है यार, मतलब बेसिक हिंदी इंग्लिश भी बोलता हूँ मैं। आई डू नॉट से, आई डू नॉट स्पीक वेरी एडवांस इंग्लिश दैट यू विल नॉट अंडरस्टैंड, ओके? सो आई थिंक दे आर थिंकिंग ऑफ स्क्वेड ट्री, हाँ हाँ, या स्क्वेड ट्री इज नथिंग बट अ लिंक लिस्ट, राइट? हाँ, तो एग्जैक्टली, तो व्हाट वी कैन डू इज we can iterate through this linked list. अब iteration, I think many of you are responding, you guys know, right? How can we iterate? So for iteration, it's very basic, right? See, first of all, always remember one thing, the very core concept of linked list: never move your head. Your head should not be moved. Your head should always be at the start point of your linked list. Wherever is the start point, your head should be there, right? Because if you will move your head, if you don't know the start point of your linked list, you can never get that. As I told you, linked list nodes are present in multiple random spaces. You cannot find the head node if you once you forget it, right? So never forget the or uh, move this head node from a start. Okay. What is happening? What is happening? We were having this head, right? How can we iterate? Let's discuss. Okay. So we first of all take a dummy node, as I said you, iterator, sorry, not dummy node. Let's take a current iterator, and we make the value of this current iterator to head. Okay, and I take this current pointer here. Now what we do, now this current pointer work is, it will just go through all the nodes of this linked list one by one, and it will print the values, right? So I will say while the current is not equal to null, while the current is not equal to null, what you will do is, you will be just moving your current forward and also printing the value of current. So you will say see out current data. अब देखो what is happening here. You were having your current at the first node, means at your head node, which is 7, right? What you will do is, you will one by one go through all the nodes 7, and what you are doing, you are first printing that node. And what does it, this current equal to current dot next means? This current is equal to current next means that my current pointer will move to its next node, right? So currently the current pointer is at 7, so 7 will be printed, okay? Then we move forward. Then it will come at 8, 8 is printed, then it's moved forward. Then it's 2, 2 is printed, it's moved forward. Then it's 5, 5 is printed, it's moved forward. Then 6 is printed, it's moved. So what we are just printing it and moving it forward. So now finally when it will reach the null, you will stop and your final traverse will be this. So this is how we print a linked list. Okay. Is this traversal and printing clear to everyone? Okay. Can we solve a problem on this? Can we solve a problem on this? So if you will see this problem, print linked list is same. It is exactly what we said, right? So this problem says that given a linked list, print all elements of a linked list separated by space followed. तो आपको लिंक लिस्ट रखी है, आपको उस लिंक लिस्ट के सारे एलिमेंट्स को प्रिंट करना है सेपरेटेड बाय स्पेस, राइट? अब वो कैसे करेंगे हम लोग ये समझते हैं, ठीक है? कैसे करेंगे? अब क्या होगा ना, व्हाट विल हैपन इज कि यहां पर we have a head node, right? This is, I think, the Java का code, and like both of them it's fine, either write in Java, either write in C++. Let's write in Java. C++ is also very similar, right? तो Java में हम लोग क्या करेंगे? I have the node, right? As I told you, what I will do, I will take the current node, okay, which is equal to head. I will take the current node which is equal to head, right? Now what I will say, okay, while current is not equal to null, अरे भाई क्या डिफरेंस है, कोई डिफरेंस नहीं है। अच्छा आप लोग चाहते हो ना, इफ यू गाइज वांट आई विल सॉल्व इन ऑल द थ्री लैंग्वेजेस। भाई देयर इज नो डिफरेंस इन जावा, सी प्लस प्लस और पाइथन। मैं तीनों में सॉल्व कर दूंगा बस। द मेन थिंग इज यार लॉजिक। इफ यू नो द लॉजिक यू कैन राइट इन एनी लैंग्वेज। इट्स वेरी इजी। नेक्स्ट हम लोग चलो अगले आगे से हम लोग सी प्लस में ही कर लेंगे इफ यू गाइज वांट। ठीक है, तो मैंने प्रिंट कर लिया। नाउ आई एम पुटिंग माय करंट इज इक्वल टू करंट नेक्स्ट, and then I will just, that's it will stop, right? So if you run this code, okay, I think you have to print the same line. Exactly, Vasim, only pointer difference is there. Don't worry, I will solve in all the three languages, don't worry. Okay, so it is done, right? So let's submit it. Python is not for DSA, C++ is best, Java is for build. So yeah, I let's not make a controversy on that, but yeah, I will say that C++ and Java are mostly the two object-oriented programming language that we take, right? Python is also there. Python is mostly for those who who want to go with artificial intelligence, machine learning, data science. For them, Python is better. But I understand well here, not in real language. Yeah, understanding makes sense, like Prakhar. And by the way, if you know just C and Python, I recommend you to go with either C plus plus because you already know C. So there's no difference between C and C plus plus. So learn C plus plus also, Prakhar. It will be helpful for you. Okay. Okay, cool. So it's done, right? And if you want, we have submitted. If you want, I will do nothing. I will take this same code, just same code. Okay. I will select C plus plus here and I will paste it here in C++. Okay, okay, exactly. The solving problem is more important. Now, I will just make two changes. First, I will put a pointer here and this pointer was replaced with the arrow and this null will be a capital null. हो गया, solved. I did some small changes and that's it. Okay, print भी तो करना है. One thing I left. So print के लिए भी we will use cout. If we go with cout, we're learning more minimum and there's no garbage collector. Okay, submit it. So you will see there's a very small difference between C++ and Java. In Java, we just have null as the small and U double L. There is no pointers actually, so we do not have this star in Java. Then here, instead of this arrow, we have a dot. This is the only thing that we have in Java, different from C++. Exactly. Yeah, do not have the language battle. And if you want, I can also solve in Python. Python is also very easy. I will take a current node equal to head. Okay. Now I will say while, up here we don't have null. Here we have none. So while current is not null, I will print current data and I will move current to the next node. And that's it. It is also solved. If there was a C, I can also code in C. But there is no C present. Okay, JavaScript is there. So let's solve in JavaScript also. If you want, I can do. Okay. So वही बोल रहा हूँ कि it depends. It's just the logic. If you know logic now, you can code in any language. So do not learn behind the language. Languages you can learn in 1 month. Like, do you think C++ is very difficult? No, bro. Java, it will take 1 month for you to understand the whole Java. It will take not even 1 month, I will say it will take 2 weeks to understand you Python, right? So the main thing is focus on problem solving. If you have good problem solving, you can do it. Yeah, yeah. Next, move to next problem. Ab dekho, just like we have solved this problem now. Similar problem is the next one. Here we have to find the length of the linked list. Not exactly the length. They are asking that you have to return that if the length of the linked list is even or not. So obviously to find if it is even or not, we have to first of all find the length and then check that whether the length is even or not. This is also a very basic question of what we did previously. It is exactly similar question. So what I will do, I will get it from here. I will get this from here. Okay. And then in this linked list, I will just put it here. Okay. I will just put it here. And then instead of printing the data, I will take a length pointer and I will calculate the length. तो मैंने length calculate कर ली, right? And at the last, just simply return that if length is even, return true, else return false. Even if you want, you can directly return the value of this thing. It will be true and false only. It is Java actually. The language I have selected is Java. So ये क्या है भाई, यहाँ पे 2 बार ऐसे क्यों दिए गए हैं? ये 2 बार क्यों दिए गए? यहाँ तो एक ही बार था ना. Here we were having 1 star. 2 stars क्या उसका भी एड्रेस दिया गया है क्या? I'm not understanding this thing. डबल पॉइंटर यूज कर रहा है यार ये. It is using double pointers. इसलिए मुझे यार सी प्लस बहुत खराब लगती है. पॉइंटर्स वगैरह कॉन्सेप्ट होता है ना, ये बहुत खराब लगता है मेरे को. तो हमने यहाँ पे हेड में भी लगा लिया एक पॉइंटर. सॉल्व हो गया, ठीक है. तो क्वेश्चन बहुत बेसिक था यार. इसमें हमें बस सिंपली आइट्रेट करना लिंक लिस्ट के थ्रू, और जो भी लेंथ है लिंक लिस्ट के हमारे, उसको काउंट करना, ठीक है. हाँ, राइट राइट राइट. सी में लोकल वेरिएबल, ठीक है. कोई बात नहीं, दैट इज नॉट अ प्रॉब्लम. So whenever there are 2 pointers na, that means it is sending you the address of that pointer also, right? So that is why you take, we are putting it here to get the value of that. Not a issue. Which language you prefer? So yeah, a code challenge in my whole college life, I did C++ only, by the way. Okay. But when I joined in my LinkedIn, I worked on uh, Java actually. But so currently, yeah, fine. Should we move forward? नेक्स्ट करेंगे, ठीक है. तो नेक्स्ट क्वेश्चन सॉल्व करते हैं यार. अब नेक्स्ट क्वेश्चन ये है, मिडिल ऑफ अ लिंक लिस्ट. इस क्वेश्चन को ना हम लोग, दिस क्वेश्चन वी विल सॉल्व इन 2 ways. ओके. Two methods are there to solve this problem, not a single method. एक काम, मेरा कॉल आ रहा है यार, शायद आ जाए. तो this is a question which is middle of a linked list. Question is very basic. You are having a linked list and you have to find the middle of the linked list, right? For example, your linked list is like this: 1, 2, 3, 4, 5, 6, 7, null. Okay, or let's say it's 1, 2, 3, 4, 5, 6. ठीक है. अब here, let's say this is the head of the linked list and this is the head of the linked list, right? अब tell me which is the middle node in the first linked list. इसमें middle node कौन सी है और इसमें middle node कौन सी है? तो देखो फर्स्ट वाला तो it's a odd length linked list. So in first one it's clearly visible that the middle node is this. Okay. In second linked list, because its size is actually even, we cannot say any specific middle node. But there are two middle nodes, 3 and 4. But in the question we will see they are saying if there are two middle nodes, means if the even count is there, then we have to return the second one, second middle. Okay, so in that case this is the answer. Now how can we solve it? First is the brute force approach. If anyone uh, beginner will solve that, he will say, Abhinav, it's very easy, just find the length of the linked list and then traverse till the half. Let's say this is my pen. Okay, if someone will ask me, okay, what is the middle point of this pen, how will I be able to find that? I will say, okay, I will first find the whole length of the pen. Let's say the pen is of 12 centimeter. 12 centimeter. Then I will say, okay, if it is 12 centimeter, I will say, okay, 6 centimeter, and I will find a middle point. Okay, right? Middle point I will find. So what will happen is, I will say, let's do one thing. Let's first find the length of this linked list. Length we know how to find. For this, length will be 7. For this, length will be 6. So we will find the length, okay? And after finding the length, if you will see, you have to just traverse L by 2 times. Let's say if L is 7, you have to traverse 3 times. So you will start your current here and your current will move 3 times, right? 1, 2, 3, and you will get this middle. In this case also L by 2 will be 3. So your current pointer will move 3 times, 1, 2, 3, and you will get your middle. Okay, so this is how actually we solve this particular problem. This is how we solve this particular problem. Does it make sense? Does it make sense? है ना? So लोग क्या करेंगे? यहाँ भी we already know how to find the length, right? So here's the question for length. So I will first of all find the length of this linked list. Okay, and after getting the length, the next thing that we will be doing is, next thing हम लोग क्या करेंगे? Next thing we'll be doing is कि I again make your current pointer equal to head. I will again make it equal to head, and then it will directly take it probably. And then I will say, okay, move how many times? L by 2 times. And move current forward. And when it will move L by 2 times, it will reach the middle, just return it. Okay, we have to return its value. So just return the data of that current. They were asking us to return the value. It's done. Okay, give me 1 minute. ठीक है, बढ़िया यार, है ना? This is done. Ab this is one way of solving this question. There is one more way of solving this question, which is that way. There the next way of solving this question is that using a concept called fast and slow pointer, and this concept will be using a lot in today's session, right? That is why I am taking this concept separately. What is the concept of fast and slow pointer? अब let's say that you have a ground, okay? You have a ground, and the length of this ground is 10 kilometer. What is the length? The length is 10 kilometer. Okay? And in this ground, in this 10 kilometer ground, there's a person here which is running with the speed of 5 kilometer per hour, and there's a person which is running with the speed of 10 kilometer per hour. Okay? So obviously this 10 kilometer per hour person will reach the end first. So when this 10 kilometer per hour person will reach the end, he will reach in 1 hour, okay? Because it's 10 kilometer, he's running with 10 kilometer per hour. So in 1 hour, it will reach the end. So in this 1 hour, where will this second person reach? This second person कहाँ जाएगा? In 1 घंटों में. So this second person will actually reach in the middle of the link, middle of this path. And this concept will be using to solve this pointer, to solve this problem. Okay? It will just reach the 5 kilometer, right? So in linked list also what we will do? We will have 2 pointers where the fast pointer will run with the double speed of the slow pointer. With the double speed, right? And when fast pointer will reach the end, slow will be at the middle and we will just return it. Exactly, yes Wasim, great, okay? तो कैसे होगा, मैं आपको एग्जांपल देता हूँ. जैसे कि मान लो 5 नोट्स है, या वो सेम ही ले लेते हैं. तो दिस इज आवर फास्ट पॉइंटर, this is our slow pointer. Okay, so what will happen? Slow pointer will move once, fast pointer will move twice. ठीक है? Then again fast pointer will move twice, slow pointer will move once. Fast pointer will move twice, slow pointer will move one. So what we are doing? We are making our fast pointer 2 times, means dot next, and slow pointer only once. So just dot next, right? Yeah, please like, whoever have joined, like, please put your attendance, please like the session. Okay? Exactly, yes, right? So up the and till when we will do that? We'll do these iterations while our fast pointer is not equal to null and our fast next is also not equal to null. So while this is the case, we'll be moving our fast and slow pointer forward. We'll be moving our fast and slow pointer forward. That's it. ठीक है? ठीक है? And you will see when it will reach the end, wherever your slow will stop, this point is your middle. This point is your middle point. ठीक है? ठीक है? ग्रेट, अमेजिंग. ठीक है ना? तो ये हमारा पॉइंट हो जाएगा. तो हम लोग यहाँ पर देखें तो कैसे करेंगे यार इस क्वेश्चन को. वी यूजिंग फास्ट एंड स्लो पॉइंटर. आई विल टेक करंट, जैसे करंट लिया है ना, आई विल टेक अ स्लो पॉइंटर इक्वल टू हेड and I will take a fast pointer equal to head. ठीक है? A slow pointer, a fast pointer. Now I will say while my fast pointer is not equal to null and my fast dot next is also not equal to null, because fast have to move twice, right? So fast and fast next both should not be equal to null. And if this is the case, what's the next thing that we have to do? So the next thing that we have to do is simply move your fast equal to fast dot next, and your slow as slow equal to uh, slow dot next. Okay, and then finally then the fast will reach the end, your slow way in the middle, just simply return your slow. Okay, that's it. Just run it and this problem will be done. अरे भाई क्या हो गया है यार? ये मैं ना भाई मैं एक बात तो बता रहा हूँ, जो मैंने अभी वो किया है ना, क्या फ्लेक्स किया है ना, कि मेरे को सारी लैंग्वेज आती है, मेरे को जावा भी आती है, मेरे को पाइथन भी आती है, सी प्लस भी आती है, जावा स्क्रिप्ट भी आती है। भाई ये बस फ्लेक्स के लिए अच्छा है, बट जब आप लोग रियल कोडिंग में आओगे ना तो इतना दिमाग खराब होगा ना भाई। भाई जावा में डॉट है, जावा में ये अच्छा डेटा रिटर्न करना है, जावा में डॉट होता है, सी प्लस प्लस में एरो होता है, पाइथन में फिर डॉट होता है, जावा स्क्रिप्ट में फिर एरो आ जाता है। ठीक है, अब मैं आपको बताता हूँ स्टैक की बात। अब स्टैक यार सी प्लस में पुश बोलते हैं, जावा में शायद ऐड होता है, डिलीट करने के लिए जावा में रिमूव होता है, हमारे यहाँ पॉप होता है। मतलब इतना ज़्यादा कंफ्यूजन यू विल फेस, तो इट्स बेटर टू फोकस ऑन वन, राइट? बट अब मेरे को क्या है, आई हैव टू लर्न ऑल द लैंग्वेजेस। उसका रीजन है बिकॉज आई हैव टू टीच, because of teaching I have to learn, right? And not just because of teaching, in work also, right? We have to do everything. Java में push, और अब देखो आई एम कंफ्यूज यार, what was your name? क्षितिज, right? I am confused यार. Okay, I am not confused with the concept is 100% clear, उसमें no one can stop me. Okay, logic of a problem, concept is 100% clear. Just this you are Sivraja, just syntax is always I forgot, and that is actually but yeah, no worries, because there was syntax, तो आपको आप सर्च करोगे how to insert in stack, you will easily get right. Main thing is content. That is why I always say, do not focus on a language, focus on problem solving and concepts. If you are good with that, you can implement it. Okay, चलो बढ़िया है, बढ़िया है, ठीक है। तो let's move to the next question. A pretty good one. So till now it was pretty basic only. The next question is good one. Okay, so let's discuss that question. So I'm working on Java backend. Great, yaar. Chitish, Java backend is actually really in demand in the industry, so you can work on that. It's nice. The question is remove duplicates from sorted linked list. What do we mean by this problem? So that they are saying that we have a linked list, right? Let's say two, then we have six, 7, 8, and null, let's say. Okay, and this is the head of the linked list that is given to you. Okay, अब your agenda is, your problem is to remove the duplicates in this linked list. अब remove duplicates means कि your linked list should look like this: 2, then 6, then 7, then 8, and then null. That's it. This is what we mean. Okay, we will remove the duplicates from this list. Only unique elements will be present. Okay, अब how can we solve this question? Let me add this in there also. Remove duplicates from sorted linked list. Exactly. तो लोग नेक्स्ट से कंपेयर करेंगे, राइट? यस, यू आर राइट। तो देखो What is a duplicate linked list? A duplicate linked list is that which is present again and again, right? 2 times, 3 times, 5 times, whatever. So in this case, you are currently your head is at 2. Okay? So first of all, what we will do is exactly. No, 2 pointers is not required, Sivraj. 2 pointers is actually not required. We'll be just using a single pointer. No 2 pointer, no hash set. Karthik, that is the brute force approach. The brute force approach is that you will create a hash set, you will add all the elements in that hash set, then you will create a new linked list. Second approach is you will take 2 pointers and then you will solve this problem. I will be using just one pointer, okay? And I will say just my code will be of 4 lines. I will just write 4 lines of code and this problem will be done. Okay, this problem will be done. How? How, Abhinav? I will tell you. Okay, so we'll discuss the most optimized way of solving this particular problem. How can we do that? Hi, DS. Hi. So how can we do that is, logic will be same. We'll be just checking the neighbor, right? So देखो, we are currently having 2, right? Obviously, if we are currently at the node, right? If we are currently at the node, and if your next node is also equal to the current node where you are, let's say you are currently at the node 2, and your next node is also 2. Okay, that means you have a repeated node. And if you have a repeated node, that means that next node should be removed. Understand what I'm trying to say? अगर आप एक नोड पे हो और अगर आपकी अगली वाली नोड की वैल्यू भी उस नोड की वैल्यू के इक्वल है, मतलब कि रिपीट हो रहा है, ठीक है? और मतलब है कि आपको अगली नोड को हटाना है वहां से. बात समझ रहे हो? जैसे व्हाट इज इन दिस केस, लेट्स टेक द करंट फर्स्ट ऑफ ऑल. I will take my current at the same where this head is. Let's remove it. It's not required. Current I took here. Okay. What I will do is I will check that if my current data. So I sometimes write dot, just assume it as column only, right? Exactly, yes. If my current value is equal to current next value, if value of my current node is equal to the value of my next node, is equal to the value of my next node, then what we will do? What we will do? So what we will be doing is I will be deleting my current next node. Ab how I will delete? It's a very important thing. Exactly DS. How we will delete is I will write current dot next equal to current dot next dot next. Ab how this is happening? Other tell me what is current dot next dot next? What is current dot next dot next? कोई बताएगा? So current is at 2, current next is also 2, but current next is 6. Means this is the node current dot next, right? Right? And I'm saying make current next equal to that node. So I'm ultimately what I'm doing, I'm making this current, you're making this current to this. And this will be de-linked from the middle. Okay? 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 Similarly, what's the next thing? Up, if it is not, and see, when I will move this now, I will not move my current pointer. My current pointer will be there only. But if it is not equal, then I will just move my current. For example, now are they equal? So my current is 2, current next is 6. Now they are not equal. So if they are not equal now, I will simply say, okay, move forward. I will simply say, move forward. Okay. Now, what's the next part? What is the next part? Up here, is its value next equal? Yes, it's equal. So if the current is equal to its next value, what I was saying, I'm saying make the current next equal to current next next. And in this case, my current next next is this one. Okay. So I will make this to point to this. Now you will say Abhinav, here we were not having just two nodes. We were having four nodes. Still two of them are remaining. What will you do? Okay, the algorithm will handle now. We have to do nothing. What the algorithm will do? The algorithm will simply do one thing. Algorithm will say, okay, Abhinav, do one thing. Do one thing. Is still current. So I have moved this current next to here, right? I'm not moving forward. Now it will again check for the same current. So this loop will run until while current is not equal to null. So again it will check for the same current. And now for this current, what is the current next? This one. It is still equal. It is still equal. So now you will check for current next next. What? Current next next. And current next next was what? Again 6. So I will make now this pointer. I will remove it from here. Okay. And I will put it here. Now again they are equal. So if they are still equal, again point it to its next next. And now next next is 7. So it will point out here. Does it make sense? Now you can see that current is not equal to its next. So if it's not equal, again the else part, it will just move forward. It will just move forward. Now here. Now again, is it equal to its next? No. Not equal. Again move forward. Simply move forward. Now is it equal to its next? Yeah. Now it is equal to its next. Now the current node is equal to its next node. 1 minute. I got a call. Okay. Huh. Are you guys there? Hello, hello, hello. DACS, Suvraj, Prakhar, Wasim, Karthik. Are you guys there? I'm back. I'm back. है ना हाँ so now current is here again you can see current next was 8 only so again I will make it current next equal to current next so it will be pointed here okay great and now finally high walk alone journey yeah sure and now finally we will have it here okay make sense hi Shivani okay so you can see here now we have finally moved the end this head is still here I will explain that part again, Prakhar. I will explain that part, okay? So what happened? We made it till the end, right? Right? And finally what happened? All our duplicates are removed. If you will see now, we are having 2. However, the link is see. First there is 2, then 6, then 7, then 8, then null. Okay? And now you must be confused with this part. Many people confused with this part. Okay, Abhinav, this all is right, but can you explain me how this 6 happened? Okay, how this for this 6 it happened. So let me explain this again. Okay, this part I will explain again. See what happened. Our current was here, right? Our current was here and was like this. So tell me Prakhar, currently, so if I will number all the nodes, right? Let me numbering all the nodes. This is 0 node, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. So currently for this current, can you tell me, can you tell me that which is the next node? For this current, which is the next node? So current is at 2, right? So my next node is fourth node, right? My value 6, fourth node. So what I will do, I will make my current next equal to point to this fourth node, right? Does it make sense? Does it make sense? Okay. To whoever who was not clear, please respond here. At least respond if it was not clear. I'm repeating. Okay. शांत रह जाओगे तो क्या मतलब है, फिर समझ में फिर से नहीं आएगा. ठीक है. अब अगेन यू कैन, अब देखो, अब व्हाट इज करंट नेक्स्ट? नाउ करंट नेक्स्ट इज 4. ओके, तो इफ करंट नेक्स्ट इज 4, इफ करंट नेक्स्ट इज 4, नाउ व्हाट इज करंट नेक्स्ट बताओ. अब करंट नेक्स्ट क्या है? बिकॉज स्टिल करंट नेक्स्ट इज 4, तो स्टिल आई विल नॉट मूव फॉरवर्ड. So again it will be pointed to current next. And now the current next is what? Now it is 5. So it will point to 5. Is still current next is same. So we are just, when we are moving this pointer, we are not moving forward. Current is still there. It will not move forward until the next value is not equal. Again it's equal. So again it will make to its current next. Now the current next is this to this sixth node. So it will point to here. Does it make sense now? And now finally the current will move forward. Does it make sense to everyone? Please confirm. Exactly. Current will move forward only for the else part. Only if when the value is not equal. Otherwise it will never move. It will keep on removing the next node. Okay. Great. ठीक है, चलो, great. ये चीज हो गई, right? This is a very good thing that we had. Now what is our next part? So let's code this thing. So what I will do, I will simply take this problem. I will say, okay, do one thing. Let's do one thing. Let's first take what? Let's first take the current node. So the current node is equal to head. Okay. Now what I will say? Now I will say, okay, let's do one thing. While current is not equal to null, what I will do? First take duplicate. So if current data is equal to current next data, what will I do? I will say, okay. Let's do one thing. Remove the current. How? So current next will become current next. And else what will happen? Else I will simply make current equal to current next. That's it. Okay. No. Okay, one more thing. Sorry. Yeah. Thanks, DS. This current next will also be not equal to null. So currents will also not equal to null, current next also. Because both should not be equal to null, na? Because we are considering current next, right? So that will also not be equal to null. Thanks for that. Otherwise it must be giving us error. At the last, return your head after removing the duplicates. हो गया? ठीक है, ग्रेट, बढ़िया. डज इट मेक सेंस टू एवरीवन? क्या ये बात सभी को क्लियर है? हाँ जी, क्लियर है राइट? चलो बढ़िया यार, ये हो गया. ठीक है, अब देखो हेड रिटर्न इसलिए कर रहे हैं ना कि बिकॉज दे वांट अस टू रिमूव द डुप्लीकेट्स, राइट? सो वंस वी हैव रिमूव डुप्लीकेट फ्रॉम आवर लिंक लिस्ट, द हेड रिमेन्स द सेम ना. यू आर जस्ट रिटर्निंग द हेड. हेड तो वही है, हमारे डुप्लीकेट्स रिमूव हो गए हैं. ठीक है, चलो ग्रेट ग्रेट. नाउ लेट्स मूव फॉरवर्ड टू द नेक्स्ट क्वेश्चन. देखो these were some basic questions that we have discussed. Now let's discuss two more very classical questions of linked list. After that, we have some very good questions like intersection of Y-shaped linked list. We have detect loop. So this is a question. These three questions are in a loop. First is detect loop. Then we have find length of a loop and remove length in a loop. Right? These three are actually in a loop that questions are present. All are loop questions. तो ये हम लोग discuss करेंगे. But yeah, before going to, and this is a part of a kind of a circular linked list. So I will also give introduction to doubly linked list and circular linked list. We, by the way, do not have much problems of the doubly and circular. Circular, we have good problems. This is a problem of circular linked list only. But for doubly, we don't have much problems, right? That is one thing. But yeah, let's discuss this reverse in a linked list. And after that, we will discuss this rotate a linked list, right? So how can we reverse a linked list? This is a very basic classical question of linked list. And if you know, for reversing a linked list, there is a 4-step process. If you remember those 4 steps ना, अगर आपको 4 स्टेप याद है, आप किसी भी लिंक लिस्ट को रिवर्स कर सकते हो. It's just a 4-step process. That's it. ठीक है? अब how we will do that? Let's see. So what they are saying is, they are saying linked list is like this. Let's say. Yeah. So I will say it is, let's say, 1, 2, 3, 4, 5, 6, 7, and then null. ठीक है, then null. And this is the head. This is the head. ठीक है, ठीक है, this is the head. ठीक है, अब क्या करेंगे हम लोग क्या करेंगे कि अब here what we will do is, this is, as I said, there is a 4-step process, and for reversing we need 3 pointers with us. So the first pointer that we need is the previous pointer that we make equal to null, and we have a next pointer also, maybe we can call it as nxt, that will also be null, and we have a current pointer that is pointed to head. So these are 3 pointers that we first of all use in reverse of a linked list. These 3 pointers are used. Ab dekho, reverse linked list is nothing. Achha, let's say first of all, let's just take it to 5, because going the dry run for all will be very long. Okay, and reverse simply means currently it's 1, 2, 3, 4, 5. It should become 5, 4, 3, 2, 1, and then null. But here also, we will just change the links of this linked list to perform this problem, to solve this problem, right? Ab how can we change the link? That is one important part. Okay, देखो, let's first put whatever pointers we have taken here. So I will take a null here, and as I showed you, कि previous is null, and also nxt pointer is initially null. Okay, nxt means next basically, and we have the current pointer here. Now what we do, we move our current pointer one by one. So I will say while my current is not equal to null, I will do one thing. I will do one thing. What will I do? I will say, okay, remember these four steps. Remember these four steps. First step is make your NXT equal to current next. So means when I'm making my NXT equal to current next, first of all, let's remove this. Let me update this title. Huh. So first I'm saying make NXT equal to current dot next. Okay? So my NXT will come at this point. At this point. Current next. Okay. Then next what I will do? Next I'm saying that make your current. So many of you have already written the code in the chat. Next I will do current dot next equal to previous. So means I am reversing the pointer. So currently this pointer is pointing towards 2. 1 is pointing towards 2. Now I will reverse it and I will make it point towards the previous of that, which is this null. I will reverse it and I will make it pointed to the null. ठीक है? ठीक है? अब next क्या होगा? Next is again, okay, so what I'm saying is first step is make your next equal to current next. So the NXT pointer came to the next of the current here. It came here. One node after your current. Okay, is this much clear? Is this much clear? Then I'm saying make current next equal to previous. So current next equal to previous means currently your current is pointing towards this node, to its next node. Now I will ask it to point towards the previous, where the previous is. That's it. That's it. Right? And once you can see currently it was pointing towards next, now it will point towards previous. And then I will make my previous is equal to current and current is equal to next. Basically, I will go for the next iteration. So now my previous will go to current and current will go to next. So ultimately what we are doing, we were having a current node and I made its pointer to point towards the previous. Their second line क्या है? Yes, second line is saying कि भाई current का जो next है, current का जो next है, make it previous. तो करंट का जो नेक्स्ट था, नेक्स्ट पॉइंटर क्या होता है? नेक्स्ट पॉइंटर क्या होता है? नेक्स्ट पॉइंटर होता है कि आपकी अगली नोट कौन सी है. तो अभी के लिए हमारी अगली नोट थी ये. अब मैं उसको पीछे कर दे रहा हूं कि भाई अब तुम उसको प्रीवियस की तरफ जाओ. प्रीवियस पीछे था तो पीछे पॉइंट करने लगा. क्या नहीं क्लियर है इसमें? समझे कि नहीं? हाँ जी, बोलिए गाइस. Okay. Yes, is it clear? Hi Nitish. Sarath, what about code visualization project? This project actually I've written, but I didn't got any time to start on that. Lot of work is there, office, then this teaching and all of that. Lot of stuff is there. But whenever I will get some scope of doing that, I will be taking that project. Okay. Previous 2 को point करेगा या null को? नहीं. Previous तो 1 को point करेगा ना भाई. Previous तो मैं आपको बिल्कुल बेसिक से बताता हूँ. I will explain from very basics. See what was happening. Initially, my previous was at null. My next was at null. And my current was at the head, right? And my pointer was something like this. Now what I said, I'm saying first make your next equal to current next. ठीक है, तो my next will go to current next. अब tell me what is current next? What is the current next? Current next is 2, right? Current next is 2. So I will make this current next, this next equal to 2, where the current next is, right? Now I'm updating the current next. I'm saying make the previous as the next of the current. तो अभी जो करंट है वो 2 को पॉइंट आउट कर रहा है. अब मैं बोल रहा हूं कि इस करंट को बोलो कि तुम प्रीवियस को पॉइंट आउट करो, और प्रीवियस क्या है? प्रीवियस है नल. तो ये करंट यहां से हटके इट विल गेट डिटैच फ्रॉम हेयर, और अब वो प्रीवियस को पॉइंट आउट करेगा. बस इतना ही तो कर रहे हैं, इसमें क्या दिक्कत है? करंट का जो नेक्स्ट है, करंट का जो नेक्स्ट है वो प्रीवियस को पॉइंट आउट करेगा पीछे. ठीक है, आपने लिंक लिस्ट पहले करी हुई है. हैव यू सॉल्व प्रॉब्लम्स ऑन लिंक लिस्ट? यस. दिस इज अ वेरी बेसिक थिंग. आई थिंक यू गॉट लिटिल कंफ्यूज. अभी समझ में आ रहा है कि नहीं आ रहा? राइट? डज इट मेक सेंस? डज इट मेक सेंस? ठीक है, तो अगर अभी भी क्लियर ना हो यार तो एक बार ट्राई करना कि क्लास के बाद गो थ्रू करना. यस, आपको समझ में आ जाएगा. अब ये हो गया. नाउ आई विल मूव माई करंट एंड प्रीवियस फॉरवर्ड. आई विल मेक माई प्रीवियस इज इक्वल टू करंट. सो माई प्रीवियस विल कम हेयर. हाँ, प्रीवियस नेक्स्ट 2 है, बट अब हम बोल रहे हैं कि वो प्रीवियस करंट नेक्स्ट 2 है, बट अब हम उससे कोड से बोल रहे हैं कि करंट नेक्स्ट को प्रीवियस के इक्वल कर दो. प्रीवियस था नल, तो हमने करंट नेक्स्ट को नल के इक्वल कर दिया. करंट का नेक्स्ट भी चेंज हो सकता है ना भाई, हम उसको अपडेट कर सकते हैं. तो हम बोल रहे हैं करंट को कि अपने नेक्स्ट को 2 से हटा के प्रीवियस पे ले जाओ. हम उससे ये बोल रहे हैं, तो उसने 2 से हटा के वो प्रीवियस पे ले गया, नल पे ले गया. ठीक है, और उसके बाद हम बोल रहे हैं कि तुम प्रीवियस को करंट के पास ले आओ. प्रीवियस इज इक्वल टू करंट, तब ये प्रीवियस ये करंट पे आ जाएगा. और फिर हम बोल रहे हैं कि करंट को नेक्स्ट पे ले जाओ, तो एक करंट यहां से उठ के नेक्स्ट पे चला जाएगा. फाइन, फाइन, cool. Up now this process will repeat. So if you see in each process what we were doing, we were just reversing the pointer. Up same thing will happen here. What I will do, I will move my next to the next node. I will make this current next to point towards the previous, and then I will move my current forward and previous forward. पहले previous होगी by the way. फिर the same thing. Next is move forward. Current next is pointed backward to the previous. Then previous is made equal to current, and current is made equal to next. Again, next will go next to current. Current will point to its previous, and then again current will move, previous will move forward, current will move forward. Again, next will go to current next. Current will point to previous, previous will move forward, current will move forward. Now you can see when finally your current has become null, your linked list is actually reversed. Linked list is now 5, 4, 3, 2, 1, what we want. Acha, in this linked list, the reverse linked list, can anyone tell me what is the head of this reverse linked list? इसका head क्या है इस reverse linked list का? तो इसका जो head है वो अगर आप देखोगे तो 5 है. 5 है ना इसका head. तो which is previous actually, right? Which is previous. नहीं, head इसका previous है. So I will simply return the previous, क्योंकि वो हमारा head बन चुका है. ठीक है, रिवर्स होने के बाद, राइट? ओके, तो हम लोग क्या करेंगे, let's write the same code here as it is the same code, not a single change is required. What I will do, I will say, let's do one thing. Let's start the, let's have the current node equal to head. Let's have the previous node equal to null. Okay, and let's have the this next node equal to null. Okay, equal to null. And after this both things are done, after these both things are done, the next thing that we will be doing is simple. While current is not equal to null, I will say, make nxt is equal to current next, make current next is equal to previous, make previous is equal to current, and current is equal to nxt. Okay, and then finally I will say, okay, let's return the previous, because after reversing, the previous will be the head of the reverse linked list. Let's compile it. Done. Let's submit it. हो गया, ठीक है, it's done. So yeah, this is how we solve this particular problem of reverse a linked list, okay, and this is how we get the code, we get the solution. ठीक है, ठीक है, तो यार ये हमारा एजेंडा है इसमें. I hope that you have got this understanding of this particular problem correctly, right? So it's being 1.5 hours. We will take a small break also, but let's do one thing. Before taking the break, let's solve this problem. Rotate a linked list, and after that probably we will take a small break, and after break we have to also discuss about doubly linked list and circular linked list, and then solve the problems for the same, right? Chalo, badhiya. So let's first discuss this problem, which is rotate a linked list. So just like we have a reverse, we also have rotate, and you will see that rotation also we will do with the help of just changing the links, nothing else. We'll just change some links and the rotation will happen. Let's see how. ठीक है, अब here they are referring to the left rotation. Left rotation means nodes will move to the left of itself. I will tell you how. Okay, so let's say that your linked list is given like this. मान लेते हैं कि आपकी लिंक लिस्ट कुछ इस तरीके से आपको दे रखी है. 1 है, देन 2 है, देन 3 है, देन 4 है, देन 5 है, एंड देन नल है. ठीक है, देन फाइनली आपका नल है. आप लोग क्या करोगे, आप क्या करोगे, आपको क्या करना होगा ना कि इस लिंक लिस्ट में आपको दिस इज द हेड गिवन टू यू. ठीक है, थोड़ा मैं लंबी ले लेता हूँ यार, क्योंकि रिवर्स करना है तो बेटर रहेगा. लेट्स टेक अ 6 आल्सो, लेट्स टेक अ 7 आल्सो, एंड देन नल. ठीक है, अब सी व्हाट आई विल डू. I have to make the left rotation. What? Left rotate. K times. कितने times? K times. So first of all, let's assume that our K is, for example, 3. Okay? हमारा K मान लो 3 है. हमारा K क्या है? K हमारा 3 है. अब if our K is 3, how the left rotation will work? So left rotation is nothing. But if let's say K is 3 and I have to do left rotation, that simply means that 3 nodes from this will come at the back. Means if you are doing K is equal to 3 left rotation, the linked list will become something like 4, 5, 6, 7, then 1, 2, 3, and 4, and then null. So what happened? Okay, okay, not 4 here. Just suppose. So what happened? We just moved the first 3 nodes at the last. We just moved the first 3 nodes at the end. That is what we did. Does it make sense? क्या ये बात समझ में आ रही है आपको? ठीक है? ठीक है? अब how can we do that? अब if you will see here also, we'll be just moving the and updating the links. हमें कुछ नहीं करना है. If we can just update some link na, the problem will be solved. See, first of all, what we do in this question, we just find the point where we have to do the division. Like in this point, you can see the rotation should happen at this point. At this point. Why at this point? Because these elements should go at the last and this will become the head. Right? Right? Exactly. It's a circular link list. So what I will do, I will do two parts. What I will do, I will first of all make this end of the linked list to point towards the front, and I will remove this to null. If you will see now, this linked list something like, and this is the head 4. So it will become what we want: 4, then 5, then 6, then 7, then 1, 2, and 3. And this is what we wanted. You can see. But how to implement this? It's really easy. What I will do, I have to reach this node, right? This node. So when the value of k is 3, I have to reach the third node. And if to reach the third node, you have to iterate k minus 1 times. Okay. So you will take a current here and you will take a last pointer here. Up last pointer, you will move till the last node. This last pointer will move till the last node. So means it will move while the next is not null. It will stop at this last node, right? And this current pointer will iterate k minus 1 times. Let's say k is 3, so it will iterate 2 times. And when it will iterate 2 times, it will reach here. Now it's very simple. Once they are done, means what I'm saying, first make the last pointer to the last node and then move your current k minus 1 times. Once this is done, do you know what you have to do? It's very easy. Just make your last next equal to it. We will do that. Yes, okay. I will make last dot next equal to head. So means this last next, which is currently null, this will actually now point to head. Okay. After that, I will make my head equal to current next. So where my current is now, it's next. This will become our head. And then I will make my current next equal to null. So my current next, this thing, this will become equal to null. So means our head will start from here. It will traverse and will go back to this with the null. Does it make sense? So now you can see we got our linked list rotated how we want. 4, 5, 6, 7, then coming back to 1, 2, and 3. That's it. We made our linked list rotated. Does it make sense? Right? This is the step that you have to follow. अब देखो इसमें एक और ट्रिक आती है. वो ट्रिक क्या है कि sometimes your value of k can be greater than the length of the linked list. अब how we can find the length? So when we will move this last pointer now, while moving this last pointer, we will also find the length of the linked list. So this last pointer will move from first node to last node, and I will just add one more in the iteration, and it will give me the length of the linked list. If my value of k is greater than n now, what I can do, see, if I have to repeat this linked list 20 times, like let's say 20 times, right? And each linked list size is 7. if you take the mod of 7 now, ultimately you have to move it 6 times only, because when you will repeat a linked list, when you will rotate a linked list equal to the length of its own, जब एक linked list को उसे खुद के length के बराबर rotate करते हो, then it remains the same. And even for k is equal to 0, अगर k 0 भी है ना, तो भी you will do nothing, you will not rotate it. Okay, so what I will say here, I will take the modulus of k with k modulus n. ठीक है, तो मैं क्या करूंगा, फर्स्ट ऑफ ऑल I will find the length. And how I will find the length? I will get the last node equal to head, and now I will say while this last node dot next is not equal to null, because we want the last second node. So while last next is not equal to null, while this last next is not equal to null, what will I do? I will move it forward, and I will also have a pointer n here, and the number of times this loop will run, I will also increase my pointer. Okay, but here what will happen, because we are just going to the last second node, it will be 1 less than the length, so I will increase it once more, and now finally I will get the length. Now the k, I will do k modulus n, so that the modulus is gone, and finally if k is 0, that means just return the head, no need to do any changes, because if you want to rotate it 0 times, no need to do any changes, simply return it. Okay, else what you need to do, else हमें क्या करना पड़ेगा, else हम लोग क्या करेंगे यार, कि यहाँ पर आके I will be saying first I will make current k minus 1 times I will move. You can see current k minus 1 times. So I will have a loop of k minus 1. I will move my current forward. Once it is reached there, next what will I do? I will make my last next equal to head. I will make my last next equal to head. After that, I will make head is equal to current next. So I will make my head is equal to current next. And after that, I will make current next equal to null. So current next equal to null. That's it. And finally return the new head. Okay. So let's run it. So current node we have not taken. Okay, it's taking a lot of time to execute. Let's refresh the site and let's try it again. Yeah, it's done. Let's stop it. हो गया, right? So it's done. We have solved our problem. ठीक है? Does it make sense? So इस तरीके से हम लोग इस प्रॉब्लम को सॉल्व कर सकते हैं. ठीक है, चलो बढ़िया. I hope this is clear to everyone how we can rotate a linked list. So we discussed how we can reverse a linked list and also how we can rotate a linked list. So guys, like what do you guys want? Should we take a break or should we solve this problem and after that we can have a break? What do you guys want? Should we first solve this problem, intersection in Y linked list, and then we can maybe have a break, because after this I have to take the doubly linked list and circular linked list. This is kind of a last problem of singly which I wanted to take. So why don't use a single for loop? Yeah, single for loop can also be used, but it's fine. Like just one while loop is extra used to find the last node and the length. It's not a problem, right? Please everyone tell me what to do. Should we solve this problem? That is what I'm saying. That first loop should require the counting, right? Okay, so let's solve this problem. Intersection in Y-shaped linked list. After that, we will have a break of 10-12 minutes, right? You can go have your dinner and whatever, and then we will come back and we will discuss about this doubly linked list. But let's first solve this problem. Okay. So what this problem is? Given the head of two singly linked lists, return the point where two linked lists intersect. So there are two linked lists present here, and they are saying they are actually intersecting at a specific point, and you have to return that point where they are intersecting. Okay. Ab, how can we solve this problem? How can we find the point where they're intersecting? Dekho. Let's say the linked list is like this: 1, 2, 3. There's a 4, there's a 5, there's a 6, there's a 7, there's a 8, there's a 9, there's a 10, there's a null. ठीक है, तो मान लो ये आपका head 1 है. So if you will see, they are having two things. They are giving you head 1 and head 2. ठीक है, head 1 and head 2. तो ये head है, head 1 है, and ये head 2 है. ठीक है, ये हेड 1 है और हेड 2 है. अब देखो हम लोग क्या करेंगे. What we will do? There are two ways of solving this problem. Do you know what are two ways? Let's first discuss the first way. Let's discuss what's the first way, okay, of solving this problem. तो जो पहला तरीका है प्रॉब्लम को सॉल्व करने का, वो बहुत ही बेसिक है. It is basically we will first find the length of the first linked list. Length 1. अच्छा मुझे बताओ कि जो पहली लिंक लिस्ट है उसकी लेंथ कितनी है? उसकी लेंथ कितनी है of the first linked list? तो first linked list having a length of 5. Okay, so I will just take a pointer and I will make its linked list as 5. Okay, now what's the length of the second linked list? Second linked list length is 3, 3, 2. It is 8. तो second linked list has a length of 8. अब आप देखो, अगर आप देखो तो आफ्टर द इंटरसेक्शन both the linked list have same size. After intersection both the linked list, it's 8, okay, not 9. So after intersection both the linked lists have same size, means the extra nodes must be present above the intersection point, here and here, right? So up, let's say that if the list 1 has, so in this case you can see the list 2, head 2 has more what I will say, this length, right? So what I will do, I will take two pointers here. I will take the pointer 1, let's say P1, and I will take a pointer 2, and whichever list is of higher length, I will increase its pointer for that particular length. For example, in this case you can see the P2, the pointer 2 is having 3 more nodes. It's having 3 more nodes. So I will move it 3 times. Okay. What repeat? Yes. Till now I have just told one thing, that length of first linked list is 5, length of second linked list is 8. Now I'm saying that one of the linked list having the extra node. So the second linked list having the extra node. and this extra node will be present above the intersection point. तो जो एक्स्ट्रा नोड्स होते हैं वो हमेशा इंटरसेक्शन पॉइंट के ऊपर ही प्रेजेंट होंगे, क्योंकि नीचे तो दोनों के लिए कॉमन ही है, इसके लिए भी दो नीचे हैं, इसके लिए भी दो नीचे हैं, तो इसके पास जो नोड ज्यादा है वो इस पॉइंट के ऊपर ही प्रेजेंट होंगे, ठीक है। तो वी नो दैट कि सेकंड लिंक लिस्ट इज हैविंग 3 मोर पॉइंट्स, राइट, इसके पास 3 पॉइंट्स ज्यादा है। तो what I can do is to make these 3 points, I will say let's do one thing, let's move this P2 3 times forward. So 1 time, 2 time, 3 time. Why I moved it 3 times forward? Because the list 2 was having 3 more nodes. So because it was having 3 more nodes, I will move it 3 times forward. Are you getting? I will move it 3 times forward. Next. ठीक है? Up you can see they are at the same level. Now when you have moved that second linked list 3 times forward, now you will move both the nodes P1 and P2 forward simultaneously. So like here you will move P1, here you will move P2, then here P1, then here P2. ठीक है? So you can see when you will move then both the nodes simultaneously, P1, P2, P1, P2, the point where they will meet, that will be your answer, your intersection point. Does it make sense? Does it make sense or not? Clear, right? Yes. Okay, great. Give me 1 minute. Give me 1 minute. चलो कोड करते हैं, ठीक है। अब कोड कैसे करेंगे? What we will do? We will just have the, first of all we'll find the length of both the nodes. So I will have a P1 which will be at the head. I will have a P2 which will be at the head 2, head 1. Okay, I will find length of both the linked lists. So I will say L1 0 and L2 0. ठीक है? I will say while P1 is not equal to null, I will move my P1 forward and I will increase the length. Okay, and while my P2 is not equal to null, I'll move my P2 forward and increase the length. So I'm making my P1 and P2 both forward, right? Fine. Fine. Now next thing. What is the next thing? Next I will say, okay, once we have got the length right, I will again make my P1 equal to head 1 and my P2 equal to head 2. ठीक है? P1 equal to head 1, P2 equal to head 2. Now what I will say? I will say, okay, once P1 and P2 we got the length, now if L1 is greater than L2, means if L1 length is greater than L2 length, so whatever is the difference, I will move my P2 forward. So I will get the difference L1 minus L2, and for that difference I will move my P1 forward. In the same case, let's say if L2 is greater than L1, then I will make P2 forward, right? So as we discussed, we move the other linked list forward with whatever extra node it has, right? And once they are the same level, I will move them forward while P2 is not equal to P1. So if you remember, we were having initially our P1 here and our P2 here, okay? But because our P2 was having extra node, 3 extra node, I first moved my P2 3 times forward. 1, 2, 3. It reached here. So after doing this, P1 and P2 both will come at the same level. And now I will move P1 and P2 while they both do not become equal. So first P1, then P2. Again P1, again P2. Okay? So I will first move P1 forward and then I move P2 forward. That's it. And then when they meet, the meeting point is the intersection point. Both are equal. You can return any of them. It's done. ठीक है? हो गया. So यार, this is how we are solving this problem, which is this intersection in Y-shaped list. This is how we are solving this particular problem. Okay. I hope that it makes sense to everyone. It makes sense to everyone, right? चलो बढ़िया, great. अब ना यार देखो है क्या कि the next topic that we will discuss after this. So we'll first discuss the. So what we discussed till now, we discussed the basics of linked list, basics of single linked list. We solved a lot of problems: how to find middle, how to remove duplicates, how to reverse a linked list, how to rotate a linked list. This is all what we discussed till now. Our next topic will be, we will be discussing about doubly linked list. Up in doubly linked list, the problems are similar, right? So if you will see, the doubly linked list problems are mostly related with trees. You have to convert a binary tree into a doubly linked list and a lot of that things. So we'll not be solving much problems on that. Second, we'll be having the circular linked list. Okay, circular linked list. अब in circular linked list, we have a very interesting problem where we have to detect and remove the loop from a linked list. This is a very important problem. So we will be detecting and removing the loop from a linked list. ठीक है? ठीक है? ये हम लोग करेंगे. And after that, once this is done, we'll be having more problems that we'll be solving. So whatever time we'll be having, okay, we'll be taking more problems, right? Thank you, sir. I loved your DP lecture. Yeah, thanks a lot, Shivangi. Actually, we have covered, so for those who don't know, we have already covered dynamic programming in these 3 lectures, where I've covered all the dynamic programming from end to end. Then we have also covered, I think, 2-part and sliding window. We have covered binary search. We have covered recursion. And in this class, we're covering linked list. So you can check out our remaining other videos of this JSM method also that is present in the channel. You guys can check that out, okay? Great. So guys, these are some topic that we'll be discussing after a small break, okay? So let's take a break of some 10 to 12 minutes, okay? Next will be array, okay? So what I will be doing is, next I will take some good problems of array, okay? Some good problems of, let's say, prefix, sum and other topics that I'll be taking in the next class, okay? Makes sense. Okay? So guys, let's have some break of 10 to 12 minutes. Maybe by 9:10 we can come back. Okay. And then we'll be solving, we'll be learning new topics and we'll be solving this. Okay, LRU Nitish, actually I've not considered for today's session because it's little complex and people are here little beginner, right? So I've not taken LRU for today. Maybe in some I will take some DSU for, I will take some this marathon for some hard questions or for some very important questions. There I will take LRU, okay? But for today I have not actually planned LRU because it will take around half an hour to discuss and then we have other things also, right? But if we will take time at the last, we'll be discussing, okay? So yeah, cool. Fine then. LRU is least recently used is the problem name. This is kind of a system design problem where we have LRU cache. How you will remove the cache which is least recently used. It is a, that is why I said it is a very like it is a little big concept. LRU, LFU. So we can maybe take a separate marathon for all these kind of system design questions they are. Okay, and I will be solving that. Cool. So cool, guys. Let's have a small break. After break, as I discussed, we'll be solving these problems. Detect loop in linked list, find length of a loop in linked list, remove loop in a linked list. Okay, and then after that, if the time remains, we'll be solving more problems. Okay, cool. Then let's have a small break. After that, we'll be coming back. Okay, please do not leave the live. If you will leave the live, the count will go down. Okay, so stay in the live, just hold it for some time. I will be coming back. Okay, and also do hit the like button here. We just have 40 likes. At least make it 45, 50. I need at least 10 12 minutes, so maybe 9:10 to 9:15 I will start. Okay, between 9:10 to 9:15 I will start. Max to max 9:15. I will not take more than 9:15. Okay, then we'll start. Okay, great, guys, great.
All you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready. all you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready. All you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready. All you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready. All you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready. We all know that the tech job market has become really challenging, and it is not always going to be like this. Seeing all this, we have come up with something that we never offer. You all know that we have been doing this 390 challenge where you finish 90% of the course. In 90 days, you get 90% of the cost. In addition to this, we have also reduced the upfront fee by 30%. So make the best use of this and invest in your skills, the all-time most valuable asset.
Hello guys, welcome back. Can we resume now? Can we resume with our topic that we planned today? Can we? Hello, hi Shivani, guys. Please write a +1 or something in the chat so that I can know that okay, you guys are here. Put a +1. Sure. Okay. Great. So what were we doing? We were doing, let me share the screen also. So we have done till now these questions. Started with how we can print a linked list. We solved this very basic question of printing a linked list, right? After that, we solved this question of linked list length even, if the linked list length is even. Then we solved middle of a linked list. Then we solved remove duplicates from a linked list, from a sorted linked list. Then reverse a linked list, rotate a linked list, and find intersection point of the linked list, right? Up this intersection point of a linked list, na, this has one more approach of solving this problem without finding the length. So that maybe you guys can try and solve that, right? So for now, let's continue with our next thing, which our next point, which is let's have the introduction to what is a doubly linked list and what is a circular linked list. After that, we'll be solving these problems: detect linked list, find loop in a linked list, detect loop in a linked list, find length of the loop, and remove loop in a linked list. Okay, so this is what the next thing that we'll be doing. Okay, so let's see. So first thing is doubly linked list. Doubly linked list, right? What do you mean by doubly linked list? What do you mean by doubly linked list? Just like in singular linked list, what we have. See, as I said, you linked list is a user defined topic. So let me update this banner. So now it's doubly linked list, right? Yeah. So what is a doubly linked list? See, as I said, linked lists are user defined. So we can make whatever changes we want. Just like in the current linked list, what we were having. We were having one data variable. If you want, you can put some more thing. Along with data, you can also put a value. You can also put whatever you want, right? So similarly in double linked list, what we do is, so what happens when we have a single linked list now? When we have a single linked list like this, yes, Prakhar, it has some limitation. The limitation is that we can only move to the next point. We can only move to the next pointer. This is the limitation in the singly linked list. Exactly. But in doubly linked list, we also have a previous pointer. Okay, and that's it. So means when you perform operations in doubly linked list, you have to also handle its previous pointer. So the class that we create, so the class node that we create in singly linked list, it looks like this. Where we have a class node, we obviously have the data, and we have node next. Means it stores the next node, right? And we also have a node previous. It stores the previous node. Okay, it stores the previous node. Okay, make sense? Okay, I hope it makes sense, right? I hope it makes sense. What's the next point? Next is circular linked list. Okay, what is circular linked list? Because circular linked list is nothing different. It is a simply a linked list which contains a loop, which contains a cycle. So if a linked list contains a cycle, we call it as circular linked list. That's it. That's it. If a linked list contains a cycle, we call it as circular linked list. How? Let's say we have a simple singly linked list. So 1, then 2, then 3, then 4, 5, 6, and then null. Okay? And this is, let's say, the head. This is the head. So this is the linked list. This is the head, right? We have this whole linked list. What if instead of null, I will point this again back to the head? Or maybe not the head, maybe in between something. So this is known as a circular linked list. Simple. Up there is very important thing that comes into picture here, that how we can traverse in a circular linked list. Because if you have to iterate in a basic linked list, what happens? You can just check if your next is null or if your current is null, we stop, right? But what we do in circular, because here your current never becomes null. Okay, so here what we do, here we take a current which is equal to head, right? Here we take a current which is equal to head, and then we say while current next is not equal to null, I move on. I move. And what I do while moving? I say, let's do one thing. Ki move your current forward. अब in this case, if you will move your current, na, you will see that it will move here. So if your current will start from here, it will go to this point, this point, this point, this point, this point. It will stop here because here its next is not null. Okay, so your loop will not execute for this current node. So this you can maybe take separately, right? This is a very basic thing how to traverse that you guys can maybe try. The one of the most important question of circular linked list comes, which is detect and remove loop from a linked list. Okay, so the first problem that we'll be solving will be how we can detect loop in a linked list. How we can detect loop in a linked list. That is the first thing that we are finding. Okay, that we are saying. Okay, ठीक है, देखो, for example, the linked list is given like this. There's a 1, there's a 2, there's a 3, there's a 4, there's a 5, there's a 6, there's a 7, there's a 8. Okay, and let's say here it is again pointing back to 4. This is what is happening. Okay, not let's to, okay, yeah, it's pointing back to 4. ठीक है, now what I will do, this is the head given to you, the head of this linked list, and you have to find that whether there is a loop in this linked list or not. Up here also we will use the approach of slow and fast pointer. We will use the approach of what? We will use the approach of slow and fast pointer. How can I use that approach? Understand very carefully. अच्छा, मान लो कि आपके पास एक सर्कुलर ग्राउंड है, ठीक है? अरे यार, मेरा छोटा बना लेता हूं मैं. एक सर्कुलर ग्राउंड है, ठीक है, और एक स्ट्रेट ग्राउंड है, ठीक है. अब इस स्ट्रेट ग्राउंड में दो बंदे वॉक कर रहे हैं. एक बंदा स्लो है, एक बंदा फास्ट है. तो फास्ट वाला बंदा बहुत आगे निकल जाता है, स्लो वाला बंदा पीछे रह जाता है. तो क्या ये दोनों कभी मिलेंगे? क्या ये दोनों आपस में कहीं मिलेंगे पूरे रास्ते में जब ये लोग वॉक कर रहे होंगे? ये कभी नहीं मिलेंगे, बिकॉज फास्ट वाला आगे निकल जाएगा और स्लो वाला धीरे धीरे चलेगा. और जब फास्ट वाला एंड में पहुंच जाएगा, स्लो वाला हमारा बीच में रह जाएगा. ये चीज हम लोग ऑलरेडी कर चुके हैं, ठीक है. बट यार, इसमें क्या होता है ना, जब हमारे पास एक राउंड होता है, मतलब राउंड पार्क है, और वहां पर एक बंदा है फास्ट और एक बंदा है स्लो, और जो फास्ट बंदा है वो स्लो से डबल स्पीड पे चल रहा है, ऐसा मान लो. इस केस में क्या होता है ना यार, कि मान लो अगर ये स्लो है, जब तक ये स्लो आधे रास्ते पहुंचेगा ना, फास्ट आपका पूरा टर्न कर चुका होगा, और जब ये स्लो पूरे रास्ते पहुंचेगा, आपका फास्ट 2 टर्न कर चुका होगा. तो रास्ते में कहीं ना कहीं तो वो इंटरसेक्ट करेंगे. कोई ना कोई पॉइंट ऐसा आएगा कि स्लो और फास्ट दोनों सेम पॉइंट पे मीट कर जाएंगे. पक्का कोई ना कोई पॉइंट ऐसा आएगा. यस और नो? आएगा कि नहीं? आएगा कि नहीं? राइट राइट. सर वही चीज हम लोग यहाँ पे कर रहे हैं. या हम क्या करेंगे, यहाँ पर एक फास्ट पॉइंटर लेंगे. विल टेक अ फास्ट पॉइंटर, विल टेक अ फास्ट पॉइंटर and we will take a slow pointer. Now what we will do is, I will move my fast pointer 2 times as we discussed, as we know previously also. Fast equal to fast dot next and slow pointer only 1 time. So slow will be slow dot next. Okay. So when fast will go 2 times forward, this is fast, right? When it will go 2 times forward, slow will just go 1 time. Now this fast will go 2 times forward, slow will go 1 time. Fast will go 2 times forward, slow will go 1 time forward. Now slow will go 1 time forward and fast will go 2 times. One and then again coming back to 4, this. Okay? And now slow will go 1 time and fast will go 2 times, so 1 and 2. And you can see they will meet at a specific point. They will meet at a point. So if the slow and fast will meet at a point, that means there is a loop. And if they are not meeting, if fast reaches the end, that means there is no loop. Is this concept clear to everyone? Is this concept of fast and slow clear to everyone? बोलिए. Right. Okay. Great. Now what will happen is, first let's implement this code, because this is the half of the problem. Yeah, I do not remember name of these algorithms, Prakar. I literally do not remember any algorithm name, because they're not algorithms, right? They are just uh, some techniques or concepts. I do not remember name. If slow out of bound, it's no loop. No, it's not slow, Malav. Malav, it's fast, because fast is moving forward, na. So when fast will go out of bound, or if fast will reach the end or the null, you will stop. Right? Right? So this is the question of detect loop in a linked list. Let's do that. ठीक है. ठीक है. तो तुम लोग क्या करेंगे यहाँ पे? What we will do is, I will be first of all taking a fast and slow pointer, and both will be at the head. ठीक है. Fast will also be at the head and slow will also be at the head. ठीक है. Great. अब next क्या करेंगे हम लोग? What is the next thing that we are doing? अब next हम लोग क्या करेंगे यार, कि I will say while, just like we did here, right? If you remember what we did here, we moved our while fast is not equal to and fast next is not equal to null. Same thing I will do, and I will move the fast and slow point. Exactly same. I will, if you want, I can copy paste. That's it. But here what will happen, that there can be a point where fast and slow can meet. So if fast and slow are meeting at a point, I can simply say return true. And let's say the whole while loop ends and they never meet at any point, then I will say return false. ठीक है? So this is how we are solving this problem. Let's submit. It's done. It's completely done. Okay. So this was one of the part of this question. This part says that you have to detect loop in a linked list. You are given a linked list and you have to find the loop. So is this thing clear? Is this part clear to all of you? Yes or no? अब देखो, next problem is find length of the loop. Okay, so maybe Ramanathan, you joined little late because we solved it previously, so I just copy pasted it. But if you want, I can explain you. So as I told you, the fast pointer will move 2 times, right? So it's making fast next, and slow is just moving 1 time. So we are moving slowness. And once the fast will reach the null or fast will reach the last node, we cannot move forward, right? If fast will reach here or if fast will reach the null when it's a non-circular array, we should stop, right? That is what we are doing. That while fast is not equal to null and fast next is not equal to null, I'm moving fast, I'm moving slow, and if fast slow meets, return true. Okay? Okay? Great. So now next question is find loop. Okay. अब देखो, here in this question they are saying, they are telling you that there will be a loop, and in some cases there cannot be any loop. Sir, क्या वो mid ही होगा? नहीं, वो mid नहीं होगा. No. It's never be a mid. वो इसके लिए है. Okay, do not get confused. It's never be a mid, right? अब next question क्या बोल रहा है कि you have to find the length of this loop. ठीक है? You have to find the length of this loop. अब how can you find the length? So that is also easy. This is just the extension of our current logic. देखो, till now what we discussed, that how we can find the loop. So whenever fast and slow pointer will meet at a point, we will say that okay, we have found a loop. Up, can anyone help me and tell me how can I find the length of this loop? Length means कि how many nodes are present in the loop. So tell me, for this example, what is the length of our loop? हमारे loop का length क्या है? कोई बताएगा? It's 5, right? It's 5. अब देखो हम लोग count कैसे कर सकते हैं? How can we count the length of the loop, right? So what we can do is exactly, Malav. This is what we will do. So we have a fast and slow pointer, right? What I will do, I will keep my fast here only. And I've moved the slow pointer forward. Okay? So for example, I will move the slow pointer forward. And let's see how many times it's moving. Until when I will move? I will move till this fast pointer again reaches the fast. Till this slow pointer again reaches the fast. So up they go. But if you will write the directly the while loop, na ki okay, while slow is not equal to fast iterate. In this case, what will happen is, in this case, what will happen is, जहां true मिला है वहीं से fast से slow तक count. हाँ, exactly. But the thing is कि हम start हमने आपको बताया था कि to iterate a circular linked list, we can use this loop. We can also use a do while loop here. तो क्योंकि देखो अगर हम simply लिखेंगे ना कि while slow is not equal to fast, move your slow forward. If we will write this now, my loop will never execute. My loop will never move forward. Why? Because initially only my slow and fast are equal. ठीक है? तो हम लोग क्या करेंगे यहाँ पर? That I will say do slow equal to slow dot next and length plus plus. Okay? And then while slow is not equal to fast. So in this case, first slow will move forward, then it will check. So what will happen? Let's say my length is currently 0. Okay? So first it will move my slow forward. So my slow will move forward and my length will increase. Now it will check while slow is not equal to fast. Yes, slow is not equal to fast. Again move it forward and increase the length. Again they are not equal. Again move it forward and increase the length. Again move it forward and increase the length. And finally move it forward, increase the length, and this time when you will check the while, it will say slow is equal to fast, it will stop, and your final length will be like this. Your final length will be like this. So it will be nothing. This question is exactly same what we did. So the only difference is, see, what I do is, I will say this is how you'll find in a loop. Okay. I will say do one thing. Instead of returning false, na, do not return false. No, do not make it. Take here a pointer is loop. We can also use while. Okay. And make this is loop false initially. Okay. And whenever you got a loop, you can make this is loop true and you can break. So means here we are, because they do not want us to check whether loop is present or not, right? So I'm not just returning true and false if a loop is present. I'm storing the output in a variable called is loop. So initially my is loop is false, and whenever my fast and slow will become equal, I will make my is loop true. Okay, guys, whoever has joined new, please hit the like button. Let's aim 50 likes by the end of this stream. Currently we have 41. Let's make it 50. Okay, और भी डिवाइस से लाइक कर दो, ठीक है, जितनी आईडी है आपकी. सो तो इससे क्या होगा कि हमें पता चलेगा कि भाई जो लूप है हमारी, वो लूप ट्रू हो चुकी है. अब देखो, if after this, if my is loop is still false, if it is still false, let's say, so if it is false means there is no loop present, and no loop present means I will simply return 0. I will return 0. ठीक है? Else what I will do, if loop is present, so if loop is present, I discuss, just copy paste this do while loop. First take the length as 0, take a do, move this slow forward until when, while slow is not equal to fast. While slow is not equal to fast. And once it's done, you can just return the length of your loop. You can just return the length of your loop. That's it. Okay? Now you can submit. Okay? So we have solved two things. We discussed how we can detect loop. We are looping twice, right? We are looping twice. So what we did, we first detected the loop. Okay, we were first detect the loop, and after detecting the loop, once I got okay, where is the fast and slow pointer, I will then count the number of nodes. Once to detect, exactly once to count. Okay, great. Up, I can't understand do while part. Okay, I will explain this do while part. So this do while part is actually used to count the number of nodes. If you want, if you are having difficulty with do while, you can use the while loop also. Sivraj, देखो do while loop क्या कर रहा है यार? What this do while loop is doing? It is just moving na, like it is just making a iteration of slow. अरे see what is do while will do. So the do while loop is saying that while, so first it will move the slow to forward. So first is making your slow equal to slow next. Okay. So the slow pointer will move to its next. Then I will increase the length. So length was initially what? 0. I will increase to 1. And then I will check whether they are not equal. If they are not equal, again do the same thing. Move next, forward, increase the length. Again they are not equal. Again move this slow forward, increase the length. Again move this slow forward, increase the length. And again move this slow forward and increase the length. So finally length is 5. It is the answer. Does it make sense? Does it make sense? Great, great. Okay, बढ़िया. So this is done. अब देखो, we have done two things. We have discussed how to detect a loop, what is slow not equal to false, where it is fast, not false, because the slow is starting from a going to fast, right? It's not false, it's fast. So we discussed how to detect a loop, and we also discussed how to find length of the loop. Okay, find length of the loop. Now let's discuss how we can remove the loop. Remove the loop. How can we remove the loop? How can we remove the loop? Let's discuss that. Okay. For removing the loop, what we can do is we will use what we have done till now. If you remember, अगर आप देखो ना, तो हमने क्या किया? हमने पहले डिटेक्ट किया, डिटेक्ट का हेल्प करके हमने लूप निकाला, लूप का लेंथ निकाला. अब लूप के लेंथ की हेल्प से हम उसको रिमूव करेंगे. We first detected the loop. With the help of detect loop, we got the length, and now with the help of the length, I will remove the loop also. I will remove the loop also. ठीक है? Let's see how I can remove it. So how I will remove it? Let's take the same loop. Okay. So it went till here. Okay. And till here, what we know? Till here we know one thing. Till here we know one thing, that so till here we know one thing. What? Key, we have started from here. We have meet at a point. Okay. And we actually have the length also, length of the loop. Okay. So we know the length of the loop, and we know that fast and slow pointer are present, right? Now I do not need this fast and slow pointer, by the way. Okay. कर सकते हैं यार. यस, आप ट्राई करो एक बार पेन पेपर पे, क्या दिक्कत है? ये पहले पूरा क्वेश्चन तो करो ना. ओके, लेट मी फर्स्ट कंप्लीट. यू कैन ट्राई ऑन पेन पेपर, यू विल गेट इट. ओके, अब 3 पे कर लो, आप 0 पे कर लो, 1 पे कर लो, सेम क्वेश्चन करेगा. एक बार रन करो ना. whenever you are coming in class, take a pen and paper with you. खुद भी एक बार ड्रॉ करके देखा करो कि क्या काम कर रहा है कि नहीं कर रहा है. जब तक आप खुद नहीं करो तब समझ में कैसे आएगा? सिर्फ देखने से समझ में नहीं आएगा. मेक सेंस, राइट? तो अब क्या करेंगे हम लोग? अब हम लोग फिर से स्टार्ट करें हमारे फर्स्ट पॉइंट से, और फिर से उन्हीं स्लो और फास्ट पॉइंटर को हम अपने, अब देखो ये नई चीजें को समझो. पहले हमने पहले क्या समझा? व्हाट वी डिस्कस टिल नाउ. We discussed till now how to detect it, and using detection we also was able to find a length. Now once we have the length, let's see how we can remove it. Okay, so for removing, we have to somehow reach the end of this linked list, this 8 node, and then I can make it as null simply, right? I can simply make it as null. Can anyone tell me how can I reach this last node? Can anyone tell me? तो मैं बता दो कैसे करेंगे. Let me tell you how we can do. देखो, I will first of all put this fast and slow pointer at the very start. I will use the same pointers and I will put it at the start of this linked list. Okay. अब देखो, I know that कि the length of the loop is 5. Okay. अच्छा मुझे ये बताओ, लेट्स से मैं आपको एक चीज दिखाता हूँ. फॉर एग्जाम्पल, जब तक नल के इक्वल, नल है ही नहीं ना भाई. यस, नल है कहाँ यहाँ पे कहाँ नल है बताओ, कहाँ पे नल आपको यहाँ दिख रहा है ही नहीं नल. ऐसा नहीं है. अब लास्ट नोड में नहीं बताया ना. वी डोंट नो द लास्ट नोड. विच इज द लास्ट नोड, हाउ टू फाइंड दैट. मैं बताता हूँ. फॉर एग्जाम्पल देयर इज अ लाइन. ओके, फॉर एग्जाम्पल देयर इज अ हाईवे एंड द हाईवे इज लाइक दिस. The highway is like this. Okay. Up when the highway is like this, let's say someone is starting from here. Okay. There are two people starting from here. Okay. Up in this highway, you know that length of this loop of the highway is 10 kilometer. Okay. For example, you know the length of this loop. Okay. And there are two person, one is slow and one is fast. अब what this fast does, fast को क्या करना था, fast को इस loop को पूरा cover करना था. Fast has to cover this whole loop and slow does not want to cover the loop. So what fast does, and let's assume that इसका length x है. We don't know the length, but it's x kilometer. Let's assume. Even we don't need this length of this part. But let's assume it's x kilometer. Okay. Now what will happen is, what I will say, this fast said, okay, I am very fast. What I will do, I will move k kilometers forward. I will move 10 kilometers forward. So what this fast will do, it will move 10 kilometers forward. So it will go, let's say after moving 10 kilometers, it reached here. 10 किलोमीटर चलने के बाद में फास्ट यहाँ पे पहुंच गया. ठीक है, तो मैंने क्या बोला, I have moved fast how much time, 10 kilometer, which is actually the length of this loop. अब मैं क्या करूंगा, now they both will move equally one by one. So now slow will move first, then fast will move, then slow will move, then fast will move, then slow will move, then fast will move, then slow will move, then fast will move. And can anyone tell me, after x more kilometers, this slow will come at this intersection point. Why? Because this part was x kilometer. And this fast will also go to this intersection point because fast has actually covered x plus 10 kilometers. And this whole is x plus 10 kilometers. So after they will move one by one, they both will must reach at the starting point of the loop, right? Let me explain it to you here. Okay. So here what will happen? Length of the loop is 5, right? So what I will do, I will first move my fast L times. So I will say, okay, my fast is there, move it L times. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I will move it 5 times. Now once it is moved 5 times, right? Now I will move both slow and fast simultaneously. So first slow will move, then fast will move, then slow will move, then fast will move, then slow will move, and fast will move. And you can see they will always intersect at the starting point of your loop. And why this is happening, I have proved you here. Why that was happening, I've already proved you here. Okay. So this is how we were doing this particular part. अब you will say, Abhinav, what you did by doing this, इससे तो कुछ हुआ ही नहीं, वो तो एक बीच के पॉइंट पे आ गए. आगे हम क्या करेंगे? अब देखो उसके आगे हम लोग क्या करेंगे, what we will do after this. अब once they are at the start point of the loop, So what I did, I first moved my fast L times, then I moved my slow and fast simultaneously until they're equal. Now when they're equal, they meet at the start point of the loop. Okay, and we know that loop contains L elements. So now if I will move any of them, fast or slow, any of them, L minus 1 times, means in this case 4 times. Let's move it. Let's move the fast one. How many times? 4 times. So 1, 2, 3, 4. It will reach at the last node, and then finally once it reaches the last node, simply make fast dot next equal to null, and then what will happen, this will be removed and it will become null. So this was a little complex process. Okay, let me try to code it simultaneously, then you guys will understand better. And also guys, I am telling, this is a difficult thing, देखो, you will not understand this in one go. So please take a pen and paper, please write in on that pen and paper, try to understand that. Okay, you will not understand just by watching this. Okay, so what I'm saying, see, first of all I will do the use this same code till finding the length. So what we were doing in this code, what were we doing, we were first having a fast pointer, a slow pointer. I was first checking whether there is a loop or not. Up, if there is no loop, I will simply return. If there is no loop, there is no need to return the like remove the loop. I will simply return. But if there is a loop, I was finding the length of the loop. I was finding the length of the loop. Now, after finding the length of the loop, what is the next thing that we will do? Next thing, as I told you, when there was the loop, I will go back. When there was a loop, it was like this, right? So मैं क्या करना था next? I was saying you, if you remember, take this fast and slow pointer both at the start. So I will take my slow at head and my fast also at head, right? Both at head we will take. Now what we will do? Now I will move my head pointer L times. So 1, 2, 3, 4, 5. So what I will do, I will take a loop of L. I will take a loop of L and I will move my fast pointer one by one. Okay, so it will reach here. It will reach here. Now I will move my slow and fast pointer both simultaneously until they meet each other. So first fast will be moved, then slow will be moved, then fast will be moved, then slow will be moved, then fast will be moved, and then slow will be moved. Now you can say the meet. So I will say while slow is not equal to fast, I will move both. I will move fast also and I will move the slow also. Okay, great. What's the next thing? When they will meet at a point, we know that it is the starting index, it is the starting point of our loop. I have to reach the end point. So for reaching end, now I will move my this fast how many times? L minus 1 times, means 4 times. So 1, 2, 3, 4. So I will move now my fast L minus 1 times. So after doing that, it will reach the last node, means this node. And then finally make its next equal to null. Make its next equal to null means the fast next will become equal to null. And okay, I think I've written in Java. Let me copy this and paste it in C++. That's it. हो गया? ठीक है? Let's run this code. Solved. Solve हो गया. ठीक है? ठीक है? So this is how guys we are solving our problem of remove loop. So I know it is a little complex problem. I totally understand that part. That is why I'm saying take a pen and paper and try. So what I will do, let me do one thing. Let me first of all send the link of this problem to you all so that you can try. So I'm opening my submission and I am sending the link of this problem to you all for understanding. So this is the problem. Okay. And I'm giving you some time. Okay. So take next 5 to 10 minutes. There is no hurry. Okay. Take some time of next 5 to 7 10 minutes. Have a break also. Take some tea, coffee, and try to solve this problem, because this is what the loop was. We discussed detect a loop. Then using detect a loop, we solve the problem. Find the length of a loop, and then using the length of the loop, we also solve the problem. Remove loop. Right. So we are done with all the three parts of this problem. Up, whatever I planned for today is done. We have some more problems to discuss, like this merge to sorted linked list problem is also there. Then this delete without head pointer is also there. If we will get time, we'll solving these problems. But before moving to that, I will give you some time to go through what we have done till now. Does it make sense to everyone? Please write a +1 if it makes sense. Please write a +1. All of you. Okay. Great. Great. ठीक है यार. So this is what we are doing. Let's take a break of some time. We'll come back maybe by again 10:10 or 10:15, maybe 10:10. Okay, not much. And after that, please do not leave. Stay here. Try to go through what we have done. I know it is little complex. That is why I've sent you the code. Open this code in your laptop. Take a pen and paper and try to understand how the things are working. When you are clear, then we'll solve our next problems of linked list. Okay, great, amazing. Yeah, Ramanathan. Please ask your doubt. You should have tell little early. But okay, I heard that doubt. Please ask me. What's the doubt, Ramanathan? क्या doubt है यार? Are you here? Well, in last element loop, can you move slow? Exactly. So because see, both are there now. Just like even in the loop now, where we are finding the length, where we move the slow pointer, there also we can move fast in place of slow. Same for the L-1 loop, we can move slow also. Even when we're starting from the front now, there also we can move slow. So it's just about pointers, no matter, because both are the same point, right? We can move any of that. Okay, great. Chalo.
All you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready.
Yeah, let's continue, guys. Are you all there? Hmm. So any doubts यार? Whatever we discussed till now. इसमें किसी को doubt है क्या? Remove loop in linked list, find length of the loop, then detect loop in linked list, and then all other things. Is this fine for everyone? Okay, great. तो हम क्या एक काम करते हैं, लेट्स मूव फॉरवर्ड, ठीक है, नेक्स्ट करते हैं. तो ये हमारा नेक्स्ट क्वेश्चन है. नेक्स्ट क्वेश्चन सेज दैट यू आर हैविंग अ यू आर हैविंग टू सॉर्टेड लिंक लिस्ट, राइट. नेक्स्ट क्वेश्चन में क्या बोल रहा है कि आपके पास दो सॉर्टेड लिंक लिस्ट है यार, दो सॉर्टेड लिस्ट है और आपको उन्हें मर्ज करना है. आपको उन दो सॉर्टेड लिस्ट को क्या करना है, मर्ज करना है, राइट. और मर्ज कैसे करना है? So that was sorted, right? The new linked list will also be sorted, right? Today I complete my 100 questions GFG. Great, Prakhar. Congrats. Okay. Huh. So you have to merge them and then return the head of the sorted merged list. ठीक है, फिर तुम उसका जो भी तुम्हारी लिस्ट है उसका सॉर्ट करने के बाद में, मर्ज करने के बाद में, you have to return the head of that sorted merged list, right? Great. So अब क्या करेंगे यार हम लोग? Yeah. So merge function will be writing obviously, and we have to see how to write that merge function. We can't just write that merge function. Okay. So how can we do this? How can we do this? We can maybe use the new node, external node, okay, and then we can put this linked list on that new external node. Okay, so let's see that how we can solve this question. How we can solve this question. So I will have the first linked list like this. So let's say 1, then 3, then 7, then 9, then null. We have 2, we have 4, we have 5, we have 10, we have 11, we have null. Okay, right, exactly. So here we would use the two pointers approach only. First will be the, so this is the head 1, right? So this is the head 1, this is the head 2. So first I will be having the head 1, and here I will be having the head 2. Okay, the head 2. Up next what we'll be doing is, I will take a pointer, let's say current 1 and current 2. Okay, and I will create a new node. अब देखो, the new linked list that we'll be creating, उसको हम इनिशियली वहाँ पे हम डेमी नोड रख लेंगे, जिसको हम लोग एज समवन आस्क्ड ना, सेंटिनल नोड. तो मैं अभी के लिए अभी क्या करूँगा, एक जीरो वैल्यू के साथ मैं लिंक लिस्ट बना लूंगा विद द नेम लेट्स से आंसर, ठीक है, वेयर आई विल पुट माई नोट्स वन बाय वन, ओके, एंड आई विल ऑल्सो हैव द हेड ऑफ दिस न्यू नोड एज हेड 3, ठीक है, और लेट्स से दिस इज करंट 3, current 3 and head 3, right? Up, so let's do this thing first. So what I'm saying create a new node, let's say head 3, that will be new node with the value 0. Now what I will say while this head 1 is not null and this head 2 is not null. So while the head 1 will not reach the null and your head 2 will not reach the null, I will move forward. So I will say while head 1 is not equal to null and head 2 is not equal to null, or means when either of them is not null, then I will take which one is smaller, right? So if head 1 data is less than head 2 data, what I will do, in the next of this head 3, I will take head 1 data, okay. So I will create a new node, let's say temp, and here I will take a node current 3, which will be equal to head 3. So I'm taking a new node temp with the data of this head 1, okay, and I will put it, so this new node will be created here, temp with this, you can see which is smaller, 1 is smaller, right? So 1 will be there, okay. Not just head, I will take 2 other nodes. Maybe I can just iterate with head because I do not need anything else, so I can maybe use head only here. So whichever is smaller, I will take that, I will put it here in the next of this current 3. So I will make my current 3 next equal to the temp, and then I will move my current 3 equal to current 3 next, okay, equal to current 3 next. Now what's the next thing? 1 minute. So I'm simply saying, Prakhar, that if your head 1 is smaller, create a node with head 1 and add it in the front of current 3 and then move the current 3, right? So I will put it here in the front of current 3 and I will move my current 3, right. Now what I will do, else if let's say head 2 is greater, head 2 is smaller, then I will, and okay, here I will also move the head 1 because we are considering head 1. Else I will take head 2, okay, I'll moving head 2, okay. So I will take this temp, I will make my current 3 next equal to temp, I'll make my current 3 is equal to current 3 next, and head 2 is equal to head 2 next, right? अब देखो, before checking this thing, I will check one more thing, that let's say even if my head 1 is null, if my head 1 is reached null, then I can't take head 1, then I will definitely take head 2 only. And if my head 2 reaches null, then I will take head 1 only. Else, like this. Okay. So if head 1 is null, take head 2. If head 2 is null, take head 1. If head 1 is smaller, take head 1. If head 2 is smaller, take head 2. Okay. And after this all is done, your linked list will be created. And because we added this 0 dummy node here, you will move your head of this linked list 1 forward of this new linked list head 3, and then just return it. So it's a little of a complex problem. Okay. But yeah, we are getting the right output. Time limit exceeded. Okay. I think there is some problem that happened because of which syntax is confusing. Exactly, syntax is confusing. The implementation is confusing, I will say. But there is some time limit exceeded that has gone. Let me see where it's having the problem. Can anyone help me find why it's giving TLE? Ah, if both are equal, so I was only saying else, last should be a else, right? Because if both are equal, it will do nothing. So last should be L. Yeah, like we are considering that part, Sivraj. Okay, it's done. So this is how we are solving this problem. Okay. Okay. So this is the code here. Is it fine? Is it fine? Let's do one thing. Let's take some 5 minutes and go through this code, and please ask me if there is any problem. Please ask me. Okay. Now let's do one thing, guys. I'm giving you one more very interesting problem, which is delete without head pointer. What they are saying is they are giving you a node and they're asking you to delete a node. Ab dekho what happens is na, you have a linked list, right? So when we have a linked list and when we have to delete a node, what we do? What we do? let's say if I have to delete this node, right? If I have to delete this node, I take a pointer one way back. Okay, I take a pointer one way back, and then I move this to this. That's it, right? That's it. So up here, what I will do, I will say do not have this. I'm saying my pointer is itself in the node which I have to delete. Means आप उसी नोड पे खड़े हो जो आपको डिलीट करनी है. तो how can you delete? This is a very tricky question. If you have to delete the next node, then you can simply move the pointer, right? If you delete the next node, we simply move the pointer. But if you delete the node where we are currently, let's say this node, delete pointer, then how can you delete? This question is. So try to solve this question. Think of it how we can solve this question. I'm sending the link of this question in the chat, and I'm giving you some 5 minutes. Okay. So take some 5 minutes and try to solve this question by your own. And after that, we'll be solving the question. प्रीवियस कैसे लोगे? डब्ल्यू लिंक लिस्ट नहीं है, आपको हेड भी नहीं दिया गया है यहाँ पे. यस, आपको हेड नहीं दिया गया है. नो, you don't have head. You just have the node that you need to delete. Okay, so try it. Let's take 5 minutes and try this. Okay. हो गया, डन, यस। कैसे सॉल्व किया यार, हाउ यू सॉल्व? तो इस में क्या करते हैं हम लोग, व्हेन वी आर गिवन, देखो टेम्प नोड क्या कर, हम बताते क्या करेंगे। देखो मुझे क्या करना है, मुझे इस नोड को डिलीट करना है, राइट? ओके, नोड इज इक्वल डिलीट नोड डी डेटा नेक्स्ट, एग्जैक्टली सही है, सही है, बट हो सकता है कि लास्ट हो तो ये आपसे बोल रहे हैं कि जो डिलीट, आप जो नोट डिलीट कर लास्ट नोट नहीं होगी, तो हम लोग क्या करेंगे यार, क्योंकि हमें इस लिंक लिस्ट से इस वैल्यू 4 को हटाना है, राइट? अब इसको हटाने के लिए लोग क्या कर सकते हैं, मैं क्या करूंगा, इस लिंक लिस्ट की वैल्यू को इसके नेक्स्ट वाले की वैल्यू के इक्वल कर दूंगा। तो आई विल मेक इट्स वैल्यू 5 एंड देन आई विल रिमूव इट्स नेक्स्ट नोड, सिंपल। So you will see ultimately 4 is get removed, right? Exactly, yes, exactly. So what I'm saying is I will make the value of data of this equal to the next data. Data of current node will become equal to the next node data, okay? And then I will remove the next node. How? Using the same technique. That's it. Oh, it's Java. Okay, great, it's done. Okay, यार, ठीक है? So guys, whatever we planned for today, we are done with all the questions, okay, that we planned for today. We started with the print linked list. We did is linked list length even. We did middle of a linked list. We did remove duplicates from a linked list. We did reverse a linked list, rotate a linked list, find intersection point in shaped list, detect loop in a linked list, find length of the loop in a linked list, remove loop in linked list, merge two sorted linked list, and delete without head pointer. So we have solved around how many questions? We solved 12 questions in today's class of linked list. So I've tried to cover all the important questions in this session. Okay. So guys, any queries, any doubt? In general, if you guys want, we can have a small doubt session and then maybe we can conclude today's session. So is there any doubt? Is there any query that you guys wanted to ask? So our next session, Sudhanshu, I was thinking to have array only. I was thinking to discuss array, prefix some questions of arrays that are important. Okay, so we'll be discussing that. Okay. Okay. So that you will get updated very soon. Sir, I have, yes, ask your doubt. So for the next 10-15 minutes, we will take the doubts. Tree and graph is remaining. I know, but before that, I wanted to go in a series. So I will do stack and queue. Then I will probably do tree and graph also. Yeah, thanks, Iman. So what's the best way to solve problem? So best way to solve problem is to first read the problem statement. Give your good amount of time in reading the problem statement. After that, try to think of the logic. Write that problem in pen and paper. Try to think of the logic. Then try to code it. And still, if you are not able to solve, you can check out online editorials. You can check out hints. You can check out video tutorials and take the help of them to solve the problem. Still, if you are not able to solve, then you will not be able to solve after checking the editorial, solve it, and then after some time re-revise it. Okay, like going through different solution, you can actually go with the editorial. You can try different other solution also if you feel you cannot do it. Okay, but you should again resolve the problem after some days if you're taking help from somewhere. Sir, I have solved 400 questions and done one stack project, but not able to solve question at interview time. So for that, it needs more practice. Yes, it's all about practicing more. See, it's not about solving 400 problems. It's about, are your concepts clear? Are you remembering the problems in the time of interview? Are you able to solve new problems? If not, then the only way, the only success mantra for DSA is to practice more, to solve more problems. That is the only way. Okay. Any other doubts? Well, what is the timing of the live? You got new journey for your life. Yeah, thanks, Ramanathan. So, for our this session, Ramanathan, our timing is 7 p.m. So every Saturday, 7 p.m. we have this DSA marathon, right? And it's of 4 hours. So, like from 7 to around 11, we have this marathon, right? And we pick a topic, we solve the questions. Sir, at interview time I am not able to solve, but after some time I am able to solve. So if this is because you are nervous, try to have some confidence, take some confidence here. Try to give mock interviews to your friends, try to challenge yourself by taking new questions. So it's just about, I think you are nervous. So be confident. There's nothing to nervous at the time of interview. The other person who is taking interview is also a human being, right? There's nothing to being nervous. Just be confident, give your best. Yeah. We have on Saturday only. So we have Saturday 7 p.m. every Saturday once in a week. We have this DSA marathon live. Okay, great. Anything else here? Anything else? Yes. You said to revise the problems. What problems you said to revise? So whatever problems are there, I will set in the description. Okay, भैया 3 सेम है और अभी डीएसए चालू कर दिया है वी वेब डेव करने को बोल रहे हैं, प्लीज कुछ बताइए. हाँ तो यार देखो, आपको दोनों ही करनी पड़ेंगे, आपको डीएसए वेब डेव दोनों चीजें करनी पड़ेंगी साथ साथ, राइट? यू हैव टू टेक बोथ ऑफ दैट प्रखर. डीएसए थोड़ा रेगुलर करो, वेब डेव आप कर सकते हो जब भी आपको टाइम मिले. So what the time gap we take? So it depends. You can take 7 day, 10 day of time gap. When you feel okay, let's try this again. You can take. It depends. Last question, I joined late. Can you explain one time in salt? Okay, last question. So last question, what we were doing, Ramanathan? We have to delete a pointer, right? So what we have to do? We are given a pointer, and we have to delete that particular node. So what I did, I made the value of that node equal to the next node. Okay. So I made this value 5, and we already know how to read the next node. So I'm changing the pointer of the next node to 6. So this next node actually gets deleted, and ultimately 4 is gone from the linked list. So we are first making the value of our current node equal to the next node, and then I'm deleting that next node. This is just 2 line code that we have done here. Okay, you can maybe see the recording. Recording will be present, Ramanathan. So if you missed something, you can check out the recording also. How to improve logic building? Awam, this I think I've told you already in the previous class. Logic building, everything, just practice. You will have more practice. Your logic building will be improved. 2 week once, weekly once revision. See, obviously you cannot revise all the problem every month, every week, right, Sivaraj? So it's depend. Let's say think, okay, let's say today I will solve binary cells problem. Go through binary cells problem that you have solved. Go through a topic wise that you have solved. So it depends. There is no formula. There is no as such schedule or a roadmap for doing this. Just do whenever you feel good. Okay. Okay, cool guys, we can conclude then. Okay, we can conclude the session. I hope it was helpful for you. Please do share it with your friends. Please do like the session if it is helpful for you. Okay, we will meet again the next week, next Saturday at 7 p.m. with a new topic. Probably it is going to be array, more questions, right? So thank you guys. Take care. Bye bye.
All you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready. We all know that the tech job market has become really challenging, and it is not always going to be like this. Seeing all this, we have come up with something that we never offer. You all know that we have been doing this 390 challenge where you finish 90% of the course. In 90 days, you get 90% of the cost. In addition to this, we have also reduced the upfront fee by 30%. So make the best use of this and invest in your skills, the all-time most valuable asset. All you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready. We all know that the tech job market has become really challenging, and it is not always going to be like this. Seeing all this, we have come up with something that we never offer. You all know that we have been doing this 390 challenge where you finish 90% of the course. In 90 days, you get 90% of the cost. In addition to this, we have also reduced the upfront fee by 30%. So make the best use of this and invest in your skills, the all-time most valuable asset.